Good afternoon, everyone. Sorry for the delay because there's some technical problem going on. So that was being fixed up here. In this laptop. So anyway, what I've done is that last night I have um, sent 3 documents. You'll find in the science and technology part, second lecture. You'll find first document is achievements of Department of Space from PIB. We will discuss in today's class what exactly was done, happened in the last 1 year, that is December up to December, it is given there. Second, I have uploaded 2 PowerPoint presentation. You will find that there's one is that whatever I was discussing. So let me just first go into that. We started with the topic of science and technology developments, and there in the last 2 classes, I have gone into respective areas there. Let's say all the strategic area I have discussed there, space, atomic, various areas of application part I have covered there. Then I have gone into defense. Yesterday we were discussing about DRDO perspective, what all technologies have been developed. Then I also discussed last class about biotechnology development, earth sciences. So whatever the development has been there post-independence. So my first purpose was that in science and technology, you know that after independence, what really the infrastructure, what type of products have been developed. That's one thing. Now what comes here? Now next part which comes here is that now we'll go to the concepts level there, so that you understand those terms. But basically remember that in UPSC prelims exam, based on the concepts, you'll get 3-4 questions regarding technology part. As I've already said in the first class, cloning was asked, somatic cell nuclear transfer, that kind of question. Geostationary orbit, that was asked in 2011 PT exam. So few questions will be linked with that. But again, what you find, few questions linked with current aspect, whether in terms of space technology or defense or biotech or nanotech or robotics, based on that question comes. What we'll do in today's class, we'll start with the space science, right? We'll start with this topic there, right? This is one topic. And what topics we'll cover? We'll cover, first thing is that about orbits. Okay, what do we mean by orbit? How many different classes of orbits are there? And what are their applications? We'll be getting to that, right? So we'll learn in today's class geostationary or polar orbit or geosynchronous, all those terminology will be there. Apart from that, we'll also go into the launch vehicles. I have said that we'll go into the basics on launch vehicles, and particularly we'll see from the PSLV and GSLV basis, right? What exactly the configuration, though for the last 10 years, PSLV and GSLV has always come in the newspaper whenever important satellite has been launched. But till yet, on the launch vehicle itself, any multiple choice question has not been asked. And if the question will be there, similar to what you had in the assignment question, right? 3 statement question, whether 2-stage or first stage cryogenic engine or something on that, by that part. Then we'll go into the satellites, the satellites part of that. And we have already covered as part of development where I have said about INSAT, GSAT, all those things. So I'll not repeat there, but just briefly, in this case, we'll go into one very important aspect is that frequency band. You'll come across whenever we launch satellite with K band, KU band, Kappa band, C band. So what exactly these frequency bands are there and where it is applied. So that's why these all come basic concepts. And then in terms of what do you mean by remote sensing? What do you mean by navigation? Right? Like for example, today's class we'll learn about Gagan. Okay, what exactly is the application of Gagan? Right? Though we have said that Navik or INSS, but in terms of positioning system. So we'll be getting to that concept there. So frequency bands, this part, and then we'll go into the application part of it. We'll be looking into those application part, right? And I'll be sharing through the videos. What I've done, all these things, what I'm going to cover in the classroom, I have already put in the slide, put in the PowerPoint there. And it's already been uploaded because now we are going to have holidays, right? There will be in between gap. So at least you should have something to refer to what exactly has been covered in the classroom. So put across in that way, right? Plus, you don't have holidays? For me, it will be holiday. The science tech class this week is the last, I think. Yes, Saturday. Then I have got the class, I think later on there. But I think, oh sorry, I thought Raksha Bandhan some holiday is there. No Raksha Bandhan holiday. You'll have the class going on there. No, Raksha Bandhan आप यहीं पे कर लेना. भाइयों और बहनों. So that part is there. But anyway, you may have other topics there, other topics which are continuing there, that part. So because most of the places there is 2-3 days holidays. You are not getting anyone in vision? 6, 7, something on that? No, the okay. Anyway, whatever may be that. So, so that is, let's say after the gap, when we meet there, at least you know exactly this all concepts there, right? And this achievement part, then in terms of achievements, we'll go into that achievements part. The document is already there. Now the first document what I've given there, I'll open that one, which you already have there. There's a, you have this converted into PDF format there. Couldn't open that? He has downloaded the, so I have to be careful, I should not. Just one second. Just let me do one thing. There is no opening of, but there is a, I think, okay. No, I wanted to just take you to that. What exactly is the part of it? That's what I've opened up that. But anyway, let me do one thing. Okay, it will not get open up. The problem there. Let me see here. Okay, now this is one document what you have here, and we'll cover in the classroom there. And along with this, what I've given there, you'll also find. Let me just put again. So in the classroom, their part, this is what today's this concept, what I will come with there. Now I have given in the PowerPoint point, this not only the development part, eminent Indians also there. I put across the eminent Indians contributions. So what I've done in the PowerPoint, I've given the photograph and a brief description about each of the Indian. So there, if you look at here, the further in terms of this part, let me come here. Eminent Indians. This is the document, and I kept it white background because sometimes students download and get a photo, printout also there, right? So accordingly, I put across there. Now, if you look at in this case, what I exactly have given in this is, now look at here. This is so first part I have mentioned about all the developments what we have covered in the classroom, and I have given in a kind of infographic ways, right? So I mentioned science tech systems in India. So you have all the description part given. Though in the classroom I have given notes. Yesterday, if you recall that notes what I have given, like atomic energy, I have taken that part from a box given in the DAE annual report. And again, I have added few points with examples on the whiteboard. DRDO part, there is one, I think you would have got that. Yojana December month, that is Science and Technology for Societal Development. And it covers every aspect of science and technology from Indian perspective. You'll find space technology, defense technology, all is mentioned there. So that DRDO part, what we have seen in the video, and at the same time, whatever examples I have given, that is given there in the Yojana magazine there. Now this is what I have mentioned there. What do you find here? What I have given here? Central Government Science Tech Departments. कई बार ऐसा भी होता है कि क्वेश्चन पूछा जाता है कि नाम दे दिया जाएगा कि this particular part comes under that. Like for example, just take an example. If you look at the nodal ministry to coordinate with any science and technology aspect of the country, that comes into Ministry of Science and Technology. Right, Ministry of S&T is there. And you know that minister in charge is Dr. Harshvardhan, right, who is in charge of that. You'll also find that Minister of Science and Technology is also given additional in charge of Earth Sciences. We have separate Minister of Earth Sciences. Now, within this, we have 3 departments. So one is the DST, Department of Science and Technology. And Department of Science and Technology is again the nodal department to coordinate with various type of activities, science and technology activities, which can be linked with other ministries and department, and it coordinates with the policy matter, implementation matter, everything DST comes. Now, second, what yesterday I said DBT, Department of Biotechnology. So Department of Biotechnology, we have Department of Biotechnology, not a Ministry of Biotechnology. At the same time, DBT does not come under Ministry of Agriculture or Ministry of Health and Family Welfare. It works within the Ministry of Science and Technology. Third department, if you come across, there is something here called DSIR, Department of Scientific and Industrial Research. And within DSIR, there is CSIR. There is a Council of Scientific and Industrial Research. So just from the India Yearbook perspective, that you should know that ministry and department. Sometimes you find a kind of a question directly asked in the exam also. Right, this is what you have there. So I put across in the flowchart there. So central science and technology ministries and department, then you have socio-economic other ministries. So depending upon what all programs are run by central government, then you have here independent research institute. Like for example, sometimes you know that academic institutions funded by central government, like IITs, NITs. But at the same time, we have IIC Bangalore also, Indian Institute of Science Bangalore. So they are independent, they work in their own domain. But sometimes the assistance may be provided for some kind of scientific projects, science and technology project from the central government. Respective ministry can give fund for that. Now you have your science and states government science and technology. So sometimes state agriculture university or R&D centers, they are funded by state governments. Then I provided here non-government organizations, NGOs. So there can be NGOs. Like I'll give one example of NGO. There's something called Hyderabad Science Society, right, which is based in Hyderabad. It is one of the society which is known for work in robotics. But it is a society which is privately owned but not the central government. And they work on this kind. And then another example, Center for Science and Environment, CSE. So they looks into science as well as environment. These two areas comes into that, right? So you'll find that linkage. Then in-house R&D part of the industries and given there. So you'll find that such kind of thing. At the same time, whatever I mentioned that again I put across in flowchart form. And I'll first go to the eminent Indians, which you have the slide there, and then I'll start with the basic concepts and all this, right? So let's look into this. This is in-house R&D. Every sometimes in the private industry, they also have R&D units. Like for example, when you talk about biopharma, I'll give one example: Cipla, Pfizer, Ranbaxy, right? Dr. Reddy's lab. So they also carry out R&D, research and development of any new type of drug molecule. So those kind of things. Let's say any automobile industry, let's say a big industry, let's say Bajaj or Maruti, they will also have R&D house within their own industrial setup. We will do the research on their aspect of that. Any type of design of automobiles or vehicles, that will come into that. So that part I've given here. नहीं नहीं उसमें ये है independent मतलब है कि they do not get fund from central government. This is not. See, I'll tell you what she's asking is a good question there. Sometimes we find autonomous organization, right, within the department ministry of autonomous organization, and they get funding from the central government, right? But when you say independent, that means they are not within the department or ministries. They exist independently, and they have got different sources of getting funds. They can get funds from the industries, they can get from private players, at the same time they can get from the government also. The private institutes, so they get the. That's what is a few of that. I'm not saying all of that. That's why independent. I've used the word independent. That means. हाँ मैं ऊपर ले जाता हूँ हाँ कौन से किस पे बताना है in-house R&D private industry. What is private industry? Which are not public company, government company नहीं है. हाँ, let's for example any auto Maruti Suzuki, just take example, is a private industry, private factory, and within that they will also have R&D house. That part is there. And when you say independent R&D institution, like I'll give you example, IAS Bangalore, Indian Institute of Science Bangalore. That is a organization. Is independent. It works independently. But at the same time, it gets fund from various aspects. But sometimes the government, but I've given the example, there can be independent here means that not totally under the ministry of or department. That is meaning of independent. When we say private here in-house, we're talking about industries, private companies, that part of it. Right? That thing is there. It's very common word. This all thing here, very common word is there. Now let's look into here. I've given this also. So I've already explained all of them. So I'll not go back to this. I've already explained DRDO, DOS, DBT, all this part I've explained there. Then I've also given now here, say, role of DST. So what I've done, all the areas of work of Department of Science and Technology, I've put in a one single flowchart. So what do you have here? Scientific programs. Like we were discussing Manak, like Kiran, like Curie, all these programs are funded by the DST. Then science and technology policy. So from time to time, there have been number of policies. The latest one is the science technology innovation policy. 2013. So that policy formulation comes from DST as a nodal center. Then what I've given here, professional bodies. Sometimes there may be a professional bodies, expert bodies, who's working within the DST, right? Then what I've given, interceptor advisory committee on departments. So sometimes what is the role I've said? DST has to coordinate with other ministries and departments. So there has to be some kind of body which can help in coordination part. Let's say, for example, if a project is on something on healthcare aspect. So healthcare aspect will come from biotechnology also. So biotechnology, department of biotechnology will also come. DST will also be there. Some other aspect will also come. So they will all get integrated. Then what I mentioned here, autonomous science and technology institutions, which is autonomous means in terms of their working. The government will not interfere in day-to-day working, but they will be supported with funding from the government. All the funding will be given by the government, right? Then you have here statutory board. Sometimes the boards will be there, which you look like. For example, we have in India Science and Engineering Regulatory Board, or Scientific Regulatory Board, SERB is there. So that Technology Regulatory Board. So this is a board is there. What is the role of board? It will take into some kind of policy matter and then regulate there. So DST has got that. And then you have scientific services given to the nation and all this. One of the very important service has become in recent time, that is in terms of the Vigyan Prasar, science communication, to develop scientific temperament, right? So this part I have put across. Then you have this part, which I have already explained in the classroom. The science and technology will be linked with every aspect of societal development. This has always been the part of the policy aspect. Then what I've given in the classroom flowchart, nuclear program, and I've given written part. So I put on the slide there. Then I have mentioned about Department of Atomic Energy and the name of organization, the factual part, which all organization comes within that. Like a few names I have already mentioned in the classroom, like Heavy Water Board, NPCIL, Bhavani, but here you have in a particular flowchart form. So that before the exam, when you review that, you know these are the organizations which are the part of DAE, Department of Atomic Energy. Like for example, like a Bhabha Atomic Research Center, Indira Gandhi Center of Atomic Research, then you have Center for Advanced Technology Indore, right, which looks into accelerator, particle accelerator and all this part. Then you have Variable Energy Cyclotron Center, VECC in Kolkata. So, and this center, VECC, played very important role in Large Hadron Collider, building that LSC. So this is the organization under the DAE there. Then you have in the given Atomic Mineral Division Hyderabad, which looks into all the uranium, all those kind of deposit and exploration part of that. So I have given the places also there. So the setup, what you come say, organization setup, you have there, all this part of that. So we'll be coming to few of them when we come to space program. This also we have gone into all the development part. And so you have here, then you have here DOS within that organization structure. इसमें सारा याद नहीं करना होगा, you don't have to memorize कि सारे labs और setup और कहाँ located है. लेकिन ये इसलिए थोड़ा बहुत important इसलिए होता है because as I said that UPSC can go into any kind of area which has not been asked in the exam. And sometimes when you read newspaper, you come across such names. If for example, last class I have mentioned Space Application Center Ahmedabad. I mentioned the first class there. So let's say this SAC name comes several times in the newspaper whenever such atlas are there. So at least you know that, okay, this is an organization which developed the atlas or maps on particular respective area. Now, when we talk about cryogenic engine in terms of PSLV and GSLV, GSLV has cryogenic engine and PSLV solid and liquid fuel. And liquid fuel perspective, there is Mahendragiri LPSC. Then you know that all these foreign satellites, whatever satellite launching is done, you'll many times cover Antrix. Antrix is a commercial arm of ISRO. Where is it located? Bangalore. So all these kind of foreign satellite systems and all, Antrix comes into that. And we are earning today revenue from there because of the kind of development we have. So I put across those kind of names there, you'll find here, right? Now after this, I have also gone into this one defense program. I put on the slide there. Yesterday you had a notes also there. Aeronautics development, light combat aircraft, Tejas, that part I have given there. Then a large number of other areas, we have industrial catalyst and food processing, all those areas are there. And slowly as we go into each topic, we'll be covering that part. Now earth sciences, yesterday I was talking about this. Polar science, glaciology, right, seismology. And what I said that you have to link with the meteorology and climate change, disaster management. So this is the one area, earth sciences, which will go to the geography segment, what you have learned from geography. There you have to apply for that. But here what will come? Technological aspect, how we do the mapping of glaciers, how we come to know that the glaciers are retreating. Now cyclone forecasting, warning, studies, so that scientific aspect comes into that. So I have put across this one. Antarctic research, we have mentioned the 3 names of base stations there. Then you have biotechnology program, DBT. I have said in the classroom 1986, starting with Department of Biotechnology. And what I have given on the slide, mandate of the DBT, which all areas there. So you remember that. कभी भी अगर ऐसा question आता है to write about any development mains exam, and they ask about any kind of areas of science and technology. So when you start writing, you have to bring about government perspective. And mandate, when the mandate and objective of setting up such departments is that you have to always give this, first is what? Infrastructure. Whether it is a biotechnology, nanotechnology, robotics, always comes to infrastructure first. What second comes? Manpower, skilled manpower. So that requires the HRD, human resource development. Then comes what? Industry and academia link, right? And आजकल एक और नया buzzword आ गया IPR, to promote intellectual property rights. So you'll find common. वो एक होता है set मसाला होता है. You know that this is the thing which you have to bring about in such answers. So here also you'll find the same way. How the biotechnology sector can be developed. Now from current aspect, what you have to add? Time and often, sometimes the government, let's say here in DBT, will come across some strategy, right? And recently there is a strategy called National Biotechnology Strategy has been brought by the central government. Because today, biotechnology sector in India is developing very fast, right? And we want to go to the next higher level. So there is a part of something called biotech parks, incubators, right, setups, and already you know that there are places where biotech parks are already operating, like Bangalore. Bangalore is one, is called Biotech Hub. You'll find different companies. Hyderabad, the biotech park there. Lucknow, there's a biotech park. Chennai, there's a biotech park. Delhi, we have a biotech park. So those are things are coming from where? Government initiatives. So I put across those point wise, what exactly is there. कभी भी अगर आंसर आएगा मेंस एग्जाम में तो ये जरूरी नहीं है कि आपको सारा पता हो. Every point is part. Like at least the 5-6 main points, if you are able to write there, your work will be done there, right? Then what I've done here, given the organization there. Like for example, I'll just mention with example, you will be able to understand. National Institute of Immunology, NII, New Delhi. And when you read from the newspaper, sometimes in the newspaper article will come from malarial vaccine. The trial going for malarial vaccine, right? And malaria from such a long time, we don't have any vaccine. Even the worldwide there is no vaccine. There are private companies also involved in making this kind of malarial vaccine, right? They are involved into that. Sometimes non-government organizations, I'll give one example, PATH, PATH, is a US-based non-government organization in healthcare. And they're also into development of such vaccine and taking to the market, right? Now NIA comes into what? DBT, Department of Biotechnology. So we are trying to develop dengue vaccine, malarial vaccine, all those kind of deadly diseases. We are working on that. So when you read newspaper and there's a name of NIA comes, so at least you are able to interconnect. How in terms of biotechnology comes into that. Then you look at here, National Facility for Animal Tissues and Cell Culture, Pune. So in terms of those preservation of tissues and having culture of cells, so there is a facility for that. This is listed. Then I've given here grants and research, infrastructure for services, HRD, then Bharat Immunological. Yesterday I said that India is a leading producer of vaccines. So we have those kind of, now but when you say Bharat Immunologicals, it is a government funded. Right? It's not a private, it's a private government funded. And there it comes into that. So this part I put across, Indian Vaccines Limited, others healthcare program, and what I've given that, in spite of all this, ICT and all this, we have a nano mission 2007, first class I mentioned, and then we have robotics development. Robotics segment will deal it separately there in more details. Now what I've done here is this eminent Indians. तो ये अभी तक इसमें क्वेश्चन आया नहीं है, मैंने क्लास में दिया, तो ये फिर वो है कि केवल जानकारी के तौर पे. तो वहाँ पर मुझे लगा कि डिक्टेशन के अच्छा है कि जस्ट पुट इन अ presentation form so that you can download and whenever you can read there. So what I've done here is Aryabhatta. Looks like Chanakya. That engineer with choti. Right. आज का चोटी वाला खूब चल रहा है. It's making all the news there. Mystery, mystery. So what do you have here? This photograph is, nobody has seen Aryabhatta, right? But just a kind of imagination. He would look like this one, right? Now, where is he linked with? Patliputra. Kusumputra, Kusumpura, that Kusumpura there is linked with that. And I've said in the class, Aryabhatiya Siddhantika. So in terms of any aspect of solar system and all this. So he's linked with Gupta age, right, that part of that. Then comes here, another great Indian, Varha Mihra, mathematician, philosopher and this one. Now, one good aspect of Varamihira, see this information, what you have on the slide, I have taken from Britannica Encyclopedia. Only thing is photograph is not there. So photograph I got from Google Image. Okay, so that it becomes interesting. You know that exactly. So Varamihira, he has written Panch Siddhantika. 5. Panch means 5. Siddhantika treatise there. He was thorough with Western astronomy. Of that time, he was thorough with Western astronomy. That means he was knowing about Greeks, Romans, even Egyptian also there. That was part of that, right? Then comes here another, is also linked with Gupta age only, Bhaskara. We have also named satellite after Bhaskara. We have satellite name also there. Now Bhaskara was a follower of Aryabhatta. Right, he was a total follower of Aryabhatta. And he has written 3 works. Laghu Bhaskariya, right? Then you have, there's another called as a great Mahabhaskariya, and then one is Aryabhatiya Bhaskariya. That's what he has written, three treatises. All these work are what? Evidence. And that indicates the research of that time. Right? So I've just put main point because not to have too bulky of that. What exactly contributions are there? Right? Now if you look at another ancient astronomer, there's a Brahmagupta. Right? He is linked with Bhinmal, Rajasthan. Yes, Bhinmal in Rajasthan. Right? And he was, like now, what is very important point? He was influenced with Byzantine astronomy. Where is present day Byzantine Empire? When you read world history, you will come across that. There's a part of Turkey, eastern part there. Turkey and all those part of Europe and all Syria and all this part. And it's the Islamic astronomy. There's, like in Hinduism, there's astronomy and astrological part. There's Islamic astronomy also. And he was aware of that. Right? And he has written those work on that. That link is there. So at least you know the main part of it, what the contribution of the person comes. Right? Then about the modern times, I have given the modern times here, Meghnad Saha. Right? J.C. Bose, Jagdish Chandra Bose, eminent botanist of India, has 2 disciples. One is Meghnad Saha and second Satyendra Nath Bose, S.N. Bose. So Jaisa Guru, Aisa Chela. So the Guru is also one of the biggest scientists, right? Eminent botanist of India. And Satyendra Nath Bose has his own kind of work, and Meghnad Saha is on. So Meghnad Saha is also linked with study of stars. Saha equation, something is there, right? And Meghnad Saha's good thing is that he was also part of this one, CSIR, right? Earlier when the British time it was formed, he was also part of that group. And there's a institute named after him in Kolkata, Saha Institute of Nuclear Physics, SINP, which has been founded by him only, right? So this one Indian, then comes here what? Satyendra Nath Bose. I have already said in the classroom, Higgs boson particle. So I have given some interesting aspect also. The name boson was given by a scientist here, Paul Dirac, right? So what was the thing? You know that क्या होता है? इंडियन का अगर कुछ काम करे रिसर्च वगैरह उस टाइम की बात है जब अंग्रेजों का समय था तो क्या होता है बाइसनेस होता है कि how the work will have standard there. So but European doesn't all accepted in publication part. So he sent his work to a publication. It was rejected. But he knew Einstein, Albert Einstein. So he sent his work to the Albert Einstein, just review what went wrong. Okay, my publication has not been accepted. So Albert Einstein worked on his theory, right, and developed something called Bose-Einstein equation. Right, this is part of thermodynamics, quantum thermodynamics, light, photon, condensation part of that. He worked on that. And the particle which follow that law was given those name boson by Dirac, another legendary scientist. That's how the name came. And how does the name Higgs boson particle Higgs has got? Peter Higgs. In 2013 Nobel Prize awarded because he gave something which was asked this year exam standard model. There's something called standard model in nuclear science which is a collection of theories which account for atomic aspect, fundamental particles. But something was lacking. What was lacking? Mass. Origin of mass. And that was given by Peter Higgs. And he said some particle, like a particle called Higgs boson, which is responsible, there is something called field. If anything comes, it gets mass or lose mass. And that came out to be true and he was awarded Nobel Prize. तो ऐसे कई चीज़ें इंटरेस्टिंग चीज़ें लिंक्ड होता है तो इन केस आई डोंट थिंक देयर विल बी अ चांस बट इफ इन केस मींस एग्जाम एनी टाइम दिस क्वेश्चन कम्स so at least from that respective area you can mention and explain on that part. Now here another I have given which you know this, Subramanian Chandrasekhar. What is Chandrasekhar limit? It has been asked in the exam also that 1.44 times mass of the sun. If any star, core of the star has got, if it is more than that, then it will end up like supernova. That's what called exploding star, right? So our sun, right, will end up with what? It will become black hole, or it will become supernova. What will become there? White dwarf. That, right? So our sun is in young stage right now. Right, this is already the hydrogen is still burning there. That part comes. So you have the Nobel Prize winner. Then comes here M.K. Venu Bapu, Manali Kalat Venu Bapu. So he is known for telescopes. Now name places. One name I have given in the class of Udaipur. Besides Udaipur, which all places in India we have telescopes, ground-based telescopes? Nainital. So one is that he has cut with Nainital. Earlier it was called UP Observatory, but now it has been renamed as ARIES, Aryabhatta Research Institute in Astronomical Science, ARIAS. So that is a 60-kilometer Devasthal. There is a place called Devasthal, 60 kilometers away from Nainital. So his role was to build those observatories, right? Then he is linked with Nizam and Nizamiya, Hyderabad. He was linked with that. Later on, he went to down south to Kodaikanal and in Kavalur, he built those kind of observatories. His role comes into that aspect there. So when you read there, you'll find that. I have just orally explained there. This, I have also said that. Dr. Vikram Sarabhai, right? एक चीज़ मैं इसमें और ऐड करें तो बाकी चीज़ आपको पता है, मैंने जो क्लास में बता दिया है कि स्पेस प्रोग्राम का है, इसरो का है और एटॉमिक एनर्जी चेयरमैन भी रहे हैं वो. एक चीज़ और है जो मैंने यहाँ स्लाइड में रखा है. He is also the founding person of IIM Ahmedabad, Indian Institute of Management Ahmedabad. Was late founded by Dr. Vikram Sarabhai. So that part is there. And one video which I played, you know that there was one thing called SITE, SITE, Satellite Instructional Television Experiment. 1975, right? We borrowed American satellite, and the Doordarshan started. There was black and white TV. Oh, याद है वो antenna लेके. So those days, started by 75 there. So it's Dr. Vikram Sarabhai's vision to have that kind of program, 75. So 75, 76. How many years? 40 years. So sometimes क्या होता है 50 years, 100 years, 75 years. Question is asked in that. So his role is that, and then People's President, Dr. Kalam. He is all continuously comes in newspaper. You will always, even after death, he is remembered that, right? अच्छा एक चीज़ है डॉक्टर कलाम के बारे में. Though I have said in that he was earlier trained as a scientist in space program, ISRO, and then he went to DRDO. Dr. Kalam as a president, when he became president, when he was offered the second time the presidency of India, right, he did refuse that. Why? Because he didn't had that kind of thing that he should get that post and be there. When he thought that people, he will not be in a position to win, and his reputation will be harmed, he withdrew. Right, that's what it is. So he's a man of dignity and very stylish hair. His hairstyle, that's really is very admirable. And he started trend with that, where people can reach to him, letter, email, and he was active even before death also. He died of massive cardiac arrest. There is a IIM Shillong. There he died of that, right? So then Raja Ramanna, he laid foundation of DRDO. So today DRDO, what we have, was started with Dr. Raja Ramanna, so from Karnataka is a part of that, and later on he moved as a nuclear scientist. He went to the BARC and became chairman of Atomic Energy Commission. So he has got two roles. One defense, second is the nuclear science. Two roles comes into that. So I have given there, and he also played important role in planning the initially 5-year plans and all this. Then Dr. Homi Jahangir Bhabha, right? Now, one aspect you will be aware that he died in plane crash, right? Switzerland. When sometimes there might be possible because Dr. Bhabha, see Pandit Nehru, when the first Prime Minister, he was very sure that we will only use for peaceful use. There was nothing was considered for atomic weapons, nuclear weapon. Even during Indira Gandhi's time, Morarji Desai, when Morarji Desai came, right in all this one, Shastri, Lal Bahadur Shastri and all, still this weapon was not considered. It is only during the Indira Gandhi regime when it was the situation became like that, where the India has to go for the weapons program. Dr. Bhabha has given that confirmation to the central government that any time, if central government wants, then the nuclear bomb can be developed within 2 years, and we can go for testing. But maybe possible something would have gone, but he died in the, that's the one of the aspect that he died in a plane crash there. maybe that. Because that is whether India has got that know-how of making the nuclear weapons, or maybe making that part of that. So that is the thing here. Now you have this J.C. Bose. Now one more thing you will be aware. I'll just add on that. He was the person who first time demonstrated wireless communication, radio communication. But he was not able to patent it or make a bird. 1 year later, Marconi patented that particular wireless communication. But he is the first person to demonstrate the wireless communication technology. But he is known for plants, study of plants and botany, right? Life. So he said that plants also have life, plants also cry, they also feelings and all this. So that part is their part of, right? So J.C. Bose comes into that, and there is one very big botanical garden named after him. Right? J.C. Bose, the name of that, Acharya Jagdish Chandra Royal Botanical Garden. That's in Kolkata. It's named after him there. Now this is C.V. Raman. So when is the National Science Day celebrated? National Science Day is celebrated on 28th February. February, right. 28th of February there. So I have said that is based on Raman's effect. That part, not the date of birth of C.V. Raman, right? So I put across that also there. Then Dr. Shanti Swarup Bhatnagar, establishment of CSIR and all. He starts something called Bhatnagar 12, right? 12 areas of scientific and industrial development. Leather, chemicals, all those areas he started, automobiles, right? And highest award, science and technology given to young scientists in India is called SSB award. Mathematical science, chemical science, engineering, all this award is given. So Shanti Swarup Bhatnagar award, he is the eminent in terms of development. Then Hargobind Khurana, right? So Dr. Khurana, he got Nobel Prize in 1968, right? And so 50 years, you can see that. Now it's just stuck to me. 1968, so next year will be 50 years, 2018. Right, it will be the 50 years, 50. 50 years of his Nobel Prize. So who knows what way question can be there. Did you get that? So I'm just giving you an idea. Sometimes the things are there because those question setters are very expert. They know that exactly what timeline is there. So 1968 Nobel Prize. So next year when exam when you appear, there will be 50 years of this Nobel Prize there. So he along with there's two scientists there. One is the Marshall Warren Nirenberg and then Holle, Robert Holle. They were awarded Nobel Prize. What is the role here? Genetic code. How gene is translated into protein. How the protein is made. So that kind of information, the entire sequence was worked out there. Dr. Khurana is also a person who has developed in the lab sequencing method. Today, worldwide DNA sequencing is done. He developed a method of sequencing. Again, his contribution comes. And lastly, he has also in the lab created artificial RNA. RNA stands for ribonucleic acid, single strand molecule. He developed in the lab, artificially created. So there is certain part, but remember that, though born in India, but he was an American citizen. His work was in the USA. That part comes into that. So Dr. Khurana then comes here, which you know that man who knew infinity, Ramanujan, right? Mathematician at par excellence. But he, that he was born into such a poor economic background, but he didn't get that support. He would have got a support, he would have been even far better, right? And he has done into integer, summands, hypergeometric series. All this he has worked into that. So I've just put across there, and so that when you come across this, one slide is I've given here, and we'll be getting into the other one, like I said there, this part. Now let us start with this. This is what you had in there, and let me go into the other parts of that. Let us understand here. So we'll start with the orbits and all this part of that. Okay, now let me ask a question. What do you mean by an orbit? When you say orbit, what does it mean? What is the meaning of the orbit? It's a path travel followed by a celestial object. That could be a heavenly object, right? Or maybe moon of the planet there. And in terms of the artificial satellite, what man-made satellites are there. Now look at here. When you talk about orbit here, I'll put across certain things. Then I'll come to the side here. So in terms of the classification orbit, the first term, the terminology which comes, orbits based on their shapes there are two types. First is called elliptical orbit. The first concept comes elliptical orbits there. See, as per the laws of gravity, right, any object which is there in outer space will follow elliptical path, right? So this is given by a very famous law, Kepler's laws of planetary motion, right? Let me write here, Kepler's law. Three laws have been given there in terms of solar system and planetary movement there. There's a motion part of that. And based on that, the first law itself says that every planet goes around the sun in an elliptical path, with sun at one of the foci, one of the focus. So any object will be part, even the man-made satellites, they follow elliptical path. And second type is called circular orbit. Now circle is a special case of ellipse, where from the center it is always equidistance. Right? I'll give you example also there. Let's say if we take about Earth, so elliptical orbit will be like this, whereas the circular will be this equidistance from the center of the Earth. Right? Now when we talk about elliptical path of any satellite there, so what do you find? There is something called near point and something called far away point. So nearest point, what is I have written here, this is called perigee, right, which in terms of Earth we have, and then farthest point, that is called apogee. Similar to what you have in case of solar system planet, aphelion, perihelion, that part is there, right? So elliptical path will not always be equally spaced out, near point and farthest point. Like for example, when you read in the newspaper when ISRO launched satellite, communication satellite, right? GSAT 17 was launched. First time you'll come across when after the launch there, that satellite has been placed into geosynchronous transfer orbit. And it is a highly elliptical orbit. What is called highly elliptical orbit? With 358 kilometers perigee. Around 400 kilometers will be nearest point. And what will be apogee? 36,800 kilometers. This is how the first time. I'm just giving example. So what I want to say, when you talk elliptical orbit, there will be near point and far away point. Right? So even when we launch a satellite, the nearest point can be sometimes 400 kilometers. And farthest point can be something around 36,000 kilometers. It can go far beyond. Now circle is a case where it is maintained by a satellite because satellite contains its own control and command system. And circular orbit comes in both the contexts, communication satellite also, remote sensing satellite. Right? So naturally what will be the elliptical orbit? But satellite today, satellite technology has advanced that it is able to trace in terms of what? Its velocity. When it goes around the Earth, that it maintains a circular path. But normally when it is launched, it is an elliptical path. Right, the first thing. Now, second aspect, when you come across here, let me put across, then I'll just switch out this one. There comes now the term geosynchronous, sun synchronous. Right, these are given in terms of the part of the shape of the orbit. Now look at here. Second aspect which I am writing here, in terms of movement of satellite, based on that, right, there are two types of orbits, right? The first one is called, what I'm writing here, geosynchronous orbit. Geosynchronous word comes. So geo means earth, synchronous means harmonized. So geosynchronous orbit is that orbit. Here the satellite revolves with respect to the Earth's, I'm writing a very important, but the Earth's rotation. Right? So if this is the Earth, so this kind of orbit, the first point comes here. Here it is in terms of Earth rotation. That means Earth rotate on its axis, and this satellite geosynchronous means it goes into this kind of orbit. So there's Earth rotation. It's synchronized with Earth rotation. Now you can ask me, there can be two ways, west to east or east to west. Let's say, for example, Earth goes from west to east. Like for example, so satellite will also go into this way. It moves into that. So there can be both the possibility, east to west also, west to east. But for communication purpose, we require same kind of harmonization, same movement there, west to east, right? And this is the, another thing is what? When we're talking in terms of Earth's rotation, see, remember the satellite is moving around the Earth, but it is following such a way, it goes around the Earth's rotation part, not the revolution part. It is synchronized to move with Earth's rotation. What is second thing? Such kind of orbit can also only be possible with the equatorial plane. That's only possible, right? But I'm using the word what? Equatorial plane. So angle could be anything. It can be 0 degree, it can be 10 degree. So what is there? They lies in equatorial plane. The second concept is this one. They lie in the equatorial planes. See, till yet I have not talked about distance. I've just said equatorial plane. Angle could be anything. Right? It can be exactly on the 0 degree or maybe 5 degree, 10 degree tilted. It can be part of it. Now what comes here? Second type, I'll come to this first. Sun synchronous orbit. Another word comes here, sun synchronous orbits there. Now sun synchronous orbits are those which is synchronized with sun's direction in the space there. Or I can simply say here satellite's movement, that is a satellite revolves here, satellite revolves with respect to the Earth's revolution. It goes with respect to Earth's revolution. So what is very important? What is revolution? Here is the rotation part. And how it looks like, we'll understand. Let's say if this is the Earth, so it is like this one. Such kind of orbits are polar orbit. So they will lie in the polar plane, not the equatorial plane. Geosynchronous, we are talking Earth's rotation, this way. It goes into that. But here we have nothing to do with the Earth's rotation on its axis, north to south, right? And what I said, the direction of the satellite over this going around the Earth will be based on sun's direction. This is called sun synchronized, right? So what is the next here point here? So such kind of orbits are based on polar planes there. Now why I'm using again plane? It can be in exact 90 degree or it can be tilted also, the orbit of that. Now how it happens there? Now see, remember that why it is called sun synchronous. The thing is that, let's say for example, if this is the Earth, now just understand, if I just say that this is the Earth, there's duster there, and let's say this is India, I have marked that this is India part is there. So remember that any satellite will always go around with respect to Earth only there. Only I'm talking in terms of the direction there. So let this satellite moves into that. But what happens as the Earth rotate and revolve, so position with the sun also changes with angle, right? Let's say for example, if it is here and the satellite is going into polar orbit like going around India, north to south like this one. As the Earth revolves and it reaches here, so what has happened? This angle has changed, right? Let's say here is that and it still is going like this. And just let's say Earth comes here. So where it was there? Like this one. It cannot be like this only. It has to move. It has to move so that it becomes like this one. So what happens in this case is that the satellite still continues the north to south, but the plane of that gets tilted every angle, and it happens like this one. Just to simply understand that 360 degree, right, happens in how many days? 365 average I'm talking. So let's say 365 1/4 day, but average. So there is almost a change of 0.8 degree per day. Just simply remember that. It requires imagination there. But simple understanding of given, the satellite has to maintain north to south. It has to always focus on Indian mass. Let's say this is India. So as the Earth revolves, so this angle with the sun has changed. So this has to also move into respect to this one. So this path gets changed. So it traverses in such a way that it always maintains with respect to India. And that will be part of any kind of country. Right, now what is here? There is a special kind of a geosynchronous orbit, what is called geostationary. Right, this is a word sometimes, like a GSAT, when you use the word GSAT. So here, the word geostationary, so why I have written here? So remember that, why I have written just to make you understand, geostationary orbit is also a geosynchronous orbit. Right, it's not a sun synchronous, it's a geosynchronous orbit, but there are certain things are there. First thing is what? First thing what comes here, it takes 24 hours of revolution, right, which you know the station means related to that position always remain fixed to the sky. So first is that it takes 24 hours of movement, which is equal to Earth's one rotation. So it always remains what? Fixed to a particular place, right, because it is relatively fixed there. It's not fixed means that it's stationary. It's basically moving, but it looks stationary from the ground. What is second here? It moves from same direction as west to east, as where the Earth rotates. Same direction is also the same. And third very important point is that the height of this orbit is not 2000 kilometer or 10,000 kilometer, but it lies something around 35,784 kilometer, or I am writing here approximately. Approximately, this is what is called as here 36,000 kilometers. 36,000 kilometers, this orbit which lies there, which is called a geostationary orbit, right, which is used for communication purpose. ठीक है, ये चीज़ याद रखना है. तो ये क्या है, कहाँ पर आता है, ऑलमोस्ट नियर टू द हाई अर्थ ऑर्बिट जाता है, मीडियम अर्थ ऑर्बिट के पास में, तो उससे एंड होता है वहाँ पर. तो लो अर्थ ऑर्बिट में नहीं आता 36,000 किलोमीटर्स. एक और बहुत इंपॉर्टेंट पॉइंट है, मैंने व्हाट आई हैव ड्रॉन हियर एलिप्टिकल, बट फॉर मेंटेनिंग कम्युनिकेशन यू रिक्वायर व्हाट इक्वल डिस्टेंस. So geostationary orbit is that orbit which is circular in nature. This is a very important point you should keep in mind. Right? Those people who cannot see at the back, let me repeat that. Geostationary orbit is a geosynchronized orbit, but not an elliptical circular orbit. Lies in equatorial plane, right? Equal distance from the Earth. Takes 24 hours of revolution, right? Direction is again west to east. So it always looks like a stationary in the outer space. And where is the location? 36,000 kilometers. So where the geostationary world. So these are four things you have to keep in that case. And what is the objective of such orbit? Communication, broadcasting. Now coming to here, polar orbit. The polar orbit, remember that. Cartosat, ResourceSat, all remote sensing satellite, Earth observation satellites, they're placed into sun synchronous polar orbit. You'll always come to the word SSPO. And always this word SSPO will come. So SSPO means is linked with this part. So what I am writing here, here comes here remote sensing. So remote sensing, or what is called as Earth observation. It is meant for Earth observation. And what is so again important about this one is that low Earth orbit. They are near to the Earth. Why? It has to observe. So they are not far away. Right? Here we are talking communication broadcasting. Coverage, we want to cover more. Here is what? It comes into low Earth orbit. So whenever you come across launch, and today I'll go into that achievements of ISRO last year, you'll find there will be 680 kilometers from the Earth's surface, right? 700 kilometers from Earth's surface. You'll not come across 36,000 kilometers. And again, very important point. That's what today's class will be very important, because whatever things you are getting here will be very concrete to the point, which will help you always remember that this kind of concept, circular orbit. Because for remote sensing, again, we require to maintain a circular path. This is also a circular orbit. So for special cases, remember that, for special cases, we have to have circular kind of orbit. Then only the application comes into that. ठीक है, कोई भी डाउट हो तो आप मुझे प्लीज पूछ लीजिए. हाँ, सिंपल सी बात है. देखो आप जियो संख्या मतलब अर्थ अपने एक्सिस में रोटेट करता है, ठीक है, ये रोटेट कर रहा है, तो वो ऐसे सैटेलाइट्स होंगे जो कि इक्वेटोरियल इस प्लेन पे ही रिवॉल्व करेगा वो, क्योंकि इसका जो मूवमेंट है अर्थ के रोटेशन के आधार पे सिंक्रोनाइज किया गया एट द सेम पेज. दैट इज कॉल्ड जियो सिंक्रोनस, राइट. बट व्हेन यू से सन सिंक्रोनाइज्ड, so sun synchronized is like this one, it goes like this way. Again it is going around the earth only. Satellite will always go around the earth's gravity is there, but it is not going this way. This is geosynchronous. It is following the polar orbit. Why it is following the polar orbit? Because it is the movement is getting harmonized, synchronized with sun's direction, with earth revolution around the sun in 365 days. That is the 1 year aspect comes there. That's why it is said. And polar orbit, what I said, they're not very far away. They're kept near to the ground. And again, here the orbit will not be elliptical. तो फिर तो बहुत बेकार हो जाएगा, कहीं पास आ जाए, कहीं दूर आ जाए, will be big problem. Again, it will maintain circular. So it will always remain fixed, circular path. Right, that's the thing there, right? Now another thing is there. I have mentioned the word what? Low Earth, high Earth, then in terms of the height from the Earth's surface, right? So from Earth's surface height, we have several type of applications there. And there, let me just come into this part. Now third aspect here, if you look at altitude or height from the surface, height of orbits there, right? So what comes the first one? The first one comes here, low Earth orbit. LEO, low Earth orbit comes into that. Now low Earth orbit goes up to how much? If we take center of the Earth, up to 2000 kilometers. I'm talking center of the Earth, right? So from here, it goes up to from 2000 kilometers. इसी में एक स्पेशल केस होता है नियर अर्थ ऑर्बिट. So near Earth orbit will be 1200 kilometers, or in terms of surface of the Earth, it will come around 400 kilometers, 600 kilometers. It will come near Earth orbit, 600 kilometers. When the atmosphere ends, and we just go to outer space, 600 kilometers, they're called near Earth orbit. They're nearer to the ground, right? Now tell me, this orbit, what type of applications are there on low Earth orbit? For what application low Earth orbits are preferred? Observation, weather forecasting, okay. So let me write here applications. One is what I've written there, remote sensing, earth observation, whatever remote sensing comes, right? Geography information collection, all will come into that. But I'll put across few more aspects of that besides that, right? But first let me come across. Low Earth orbit, particularly near Earth orbit, is a place in the outer space which is also known for astronomical observation. You'll find astronomical telescope. One aspect you will find in low Earth orbit is the astronomical telescopes or observatories. I'll give you an example. Very often this example comes. Hubble's telescope, Hubble Space Telescope, Kepler Space Telescope, and even our AstroSat is in the low Earth orbit, right? So just take example here. Hubble Space Telescope is NASA's celebrated telescope which has helped understanding about various aspects of stars, right? When it was launched, 1990. It has already completed 25 years of its existence, right? And then in 2011, NASA brought another telescope called Kepler Space Telescope. Kepler was brought to study exoplanets. What is the role of Kepler Space Telescope? Exoplanet or Earth-like planets. And you know, recent times, so many discoveries have been there. A lot of things were there. कई बार ऐसा Kepler with number will come there. And 2016, there was a question of Goldilocks, Earth 2.0. Second Earth was found. So where all these telescopes are there, they are not very, very far away. They are low Earth orbit, right? Now my question, why low Earth orbit? We can place anywhere in the outer space, no? Why is such kind of area is kept? Even you can find here AstroSat. I'll give the Indian example also there. Why they are kept into such kind of orbit there? Why not into higher orbit or put in 36,000 kilometers? There also it can operate. One thing is what? We are having the study of universe. So you know that most of the radiation get filtered out where? Atmosphere. Right? Before it reaches ionosphere and all gets go. So what is one objective? To get all those X-rays, UV rays which are coming to the Earth. So they can be only captured with just into that particular height. So that the observation images which can be developed and sent back to the Earth. Right? So main objective is that whatever radiation coming to the Earth, right, and particularly from the height of 600 kilometers from Earth's surface, that can be captured there. And in terms of again, second very important objective, if anything goes wrong, can be repaired. Getting my point? If anything goes wrong, can be repaired. If you put in high Earth orbit, it's out of the reach. If something goes wrong, you cannot do anything. But here you can, and that's why Hubble Space Telescope was having a faulty mirror, which was serviced by astronauts. Astronauts go to the outer space and what you call spacewalk, and they've corrected because there you can repair, you can have service mission. So low Earth orbit kept into that. One is that observation, radiation coming, जो भी radiation आ रहा है उसको capture करना, X-ray, UV rays, क्योंकि उसके बाद क्या atmosphere में filter out हो जाता है, so we can get the data. And second is that if any problem happens there, that can be taken care of. So NASA has been, that's why, using low Earth orbit. But today it is possible to put in high Earth orbit, there is no problem. But this is one objective which I've said. Now tell me which is another thing you will find in terms of low Earth orbit application. One I've given the telescope and observatories. That part comes. Again, it's a very important area for examination, what I'm writing here. Second application of low Earth orbit is the space stations. Right? Space stations in the past, which have been built there, And today the presently International Space Station, ISS, which is currently operating. And China is also, Chinese are also building their own space station independently, right, without any kind of collaboration. Now, ISS, if you look at International example here, International Space Station, it continuously comes in the news, and recently it has come in the news in terms of SpaceX, right, all the logistics and all, right. So there's a space station, this part. This is the presently operable one, which you see in the Hollywood movies also, the Gravity, right, Interstellar, Martian, all this have come there. So how far is that? Just 480 kilometers from the Earth's surface. So when the Twin Towers were, right, there was a terrorist attack. At that time, even the smoke which coming from that collapse of the building, it was observed by the astronauts there in the International Space Station. International Space Station is the place where there have been tourists also there who have visited and come back. Right? Those who can give money, they can go and can come back there. Right? Now, what is the main objective? Why to build this kind of? Why to invest billions of dollars in making such kind of a station there? Low Earth orbit. Huh? But it's tourism. But tourism will take time, right? But that is a one type distant kind of objective. But what is the main objective? Like near, primarily used for? So that again will be not primary objective. What I'm saying, the near point objective, yes. Huh? Fuel away, right? You were saying.
If some time when the astronauts going from here, they stay over there, they do their research work and then they come back.
Okay. Very simple. This thing is that International Space Station is nothing but a lab. It's a microgravity lab. One aspect is that a lot of research is carried out in the station there, because naturally there is zero gravity, right? So many type of experiments are carried out. So what I'm writing here, if you look at, I'll just remove this part. If you look at the part, one is that microgravity experiments, and you know that when the astronauts go there, they also carry MIT, Princeton, Harvard, number of such kind of a project, small project, and they conducted experiment in the International Space Station. So one is that the part is that it is used as a microgravity lab, and we can carry out any kind of such kind of experiments. It's a kind of laboratory, lab is there, right? Now remember that International Space Station is always manned, is never abandoned. There are always 6 crew members. So new crew members get there and the others come back to them. It always gets replaced, right? And there is one person from Indian origin, what's her name? Who has one of the longest stay, Sunita Williams, right? One of the longest, but her record has been broken, right? But she stayed for a long time. And what was the marked change in his body? In her body? She gained height. She gained height there. Because bone can also undergo changes when you stay for a long time in such kind of environment, right? So as some inches he grew taller there, right? For staying there, right? So a lot of impact happens there, right? So we can carry out photosynthesis, bacterial growth, any kind of metallurgical experiment. There's a kind of lab there. Okay, now comes the next one, second. What is second objective? There's one aspect, is a laboratory. One can carry out experiment. Now what is second there? Somebody has said here, it's all right there. What is there? Is a kind of terminal, space terminal, right? Another thing is what? Called space terminal. Now what is space terminal? What you have seen in the movie there. Let's for long space voyage, manned voyage. There's a man going to the Mars. And it is very soon going to happen in our own lifetime. In a years, NASA is having very ambitious plan to put humans on Mars. And it will happen in our lifetime only, we'll see that. Just like Apollo mission, when man landed on moon, right? There's a Neil Armstrong, Edwin Aldrin, right? Which has again came in the recent news also there. So what is the plan going? Putting man on Mars. So it can serve as a terminal point, right? If let's say anything goes wrong, it can be repaired there. It can be serviced there, instead of coming back to the Earth. So that kind of objective is there. And what is third here, which I said there, space tourism. So this is another aspect coming up. Science Reporter magazine has come up with all this coverage there. SpaceX, Dragon rocket, Falcon 9. What is Falcon 9? Falcon 9 is reusable. Dragon is just simply like a taking the logistic and putting to that, right? Now what I said is the Chinese are also building. So what is the name of the Chinese space station? It is given. Is a हमारे चीनी भाइयों का स्वर्ग है वो. It is a heavenly award of Chinese people there. And in Chinese, it is called Tiangong. What is called there? Tiangong. Tiang, Tiangong. In right, Chinese called Tiangong. In Hindi means Swarg, right? So it is Swarg for Chinese people. So that is what they are building there, Tiangong. So how the space stations are built? Block by block, right? You take the module, and then docking is done. Presently, space station, International Space Station is as big as a soccer ground, football ground. So, and it's a partnership of 5 space agencies. Which are those? I'm just providing those information. This ISS is a part of 5 space agencies who have developed this large football field size of a space station and operating it right now. So it's not completely American. Even Russians are also there. Yes, so let me write here. So you have here, one is NASA. I'll write on the top there. Then you have Roscosmos. There's the Russians. Earlier during Cold War, they were building separately. But then after that, they collaborated together. And today, you know that US and Russia in space program are coming together. They're working with that. Even Russia collaborates with European country also, ESA. So next comes what? ESA, European Space Agency. Then comes what? JAXA. Japan. अब कई बार पढ़ेंगे जापान का. ये चाइना अपना इंडिपेंडेंट कर रहा है, तो JAXA is there. Japan Exploration Agency, and one more is there. See, when you say European Space Agency, the France also comes. France is also part of European Space Agency. And though France is independent also there. What is called CNES, right? Where you come across CNES. What is full form CNES? France का जो है, उसका नाम CNES है. तो CNES का full form क्या है? It's a French word, Centre National Etudes Spéciales. That is it. Centre Etudes. I will write that. It's a French word, Centre Etudes, right? Then here, Centre National. This is French. This is French. NITONAELE. Then Etudes. Then Spéciales. That is a part of that. This is a French word. That means National Center for Space. Right? That is a English word there. So this is part of European Space Agency. And what I want to say, one more is there, CSA, Canadian Space Agency, Canada. Right? The 5th country comes Canada. So Canadian Space Agency, the part of ISS there. Right? India का अभी कोई उतना ख्वाब नहीं है. Right? Why? We don't have manned spacecraft. What I said, module. It has to be done there. So maybe when we have our reusable launch vehicle, one day we will also have our own Swarg there, that we can construct those kind of a system there. So presently we don't have. Maybe after 10 years, 20 years, who knows? Indians may also try for that. ISRO may also come into that. Right? Next 5 years, space station? There is a news has come there. Dr. A.S. Kiran Kumar, he said that. So presently that is. So what is first requirement? Manned spacecraft. Then only we can carry out this one, right? So is it clear here? So what we have given? First is astronomical telescope observatory. Second is a space station. And what is third, which you have said? Disaster management, meteorology. So what is comes here? Remote sensing. Earth observation, remote sensing. That is a part of it. Clear? So remote sensing application, wherever it comes into that. All right. Now coming to medium Earth orbit. This is given about low Earth orbit. Now medium Earth orbit. Now medium Earth orbit. I'm coming to next one is number here 2. Small. I'm following the same thing. Height of orbit. I've used the small there. Low Earth orbit within that ABC. Right. Now I'm coming to second. Sub point there. हाँ. रिमोट सेंसिंग मतलब जो हम मतलब स्पेस से हम उसको ऑब्जर्व करते हैं, मतलब सेंस करते हैं, एंड दैट यूजेस रेडिएशन, कैमराज, इसलिए अर्थ ऑब्जर्वेशन को ही करते हैं. रिमोटली सेंस मतलब उसको इंटरचेंजेबली हम यूज़ करते हैं. इन सिंपल लैंग्वेज अर्थ ऑब्जर्वेशन व्हिच कम्स इनटू दैट. तो जो भी डेटा हमें एक्वायर करना होता है, नेचुरल रिसोर्स जितने भी है, तो वहाँ एप्लीकेशन आता है. डिजास्टर मैनेजमेंट आएगा, साइक्लोन फोरकास्टिंग, वार्निंग, वो सारी चीज़ें. व्हिच वन? Yes, polar planes are low Earth orbit. That's what I said, no? Here comes the low Earth orbit. Right, we bring it to that. 600 kilometers, 700 kilometers. Will not be 36,000 kilometers. 36,000 kilometers comes here. Geostationary. वहाँ पर आता है ना? ये सारी चीज़ें हैं ना, मतलब वन टाइम है, लेकिन एक बार आप समझ जाते हो, once you understand. So when you read newspaper, you will be able to understand at the same time if UPSC use such keywords. So you will not make any kind of wrong decision in the question there. That's why it becomes there. Right? Now I'm coming to medium Earth orbit. Now what is medium Earth orbit? Where it goes up to? See, medium Earth orbit, MEO, it extends to from 2000 kilometers, I'm writing the bracket, and it goes up to the 35,784 or 36,000 kilometers. This range is called medium Earth orbit. Right? Now tell me application. What type of orbits and their applications will be of medium Earth orbit? So first one, which I'll give very important application, GPS, Global Positioning System. Right? All such GPS system, right? GPS systems, how many satellites are there the part of GPS system? Minimum 3 can operate, but American GPS, how many are there? 32 satellites, 32. Different position and angles, right? 32 satellites, it just looks like this one. If I just draw a diagram of any GPS system, they are placed into different type of angles there. Orbits will be there, and they will be inclined at different angles. They can, okay, what is the main aspect? Positioning and tracking. What is the positioning? You require direction, right? Longitude, latitude, altitude, depth. So it is like almost like this one. If this is the Earth, you'll find there are different satellites into different kind of orbits there. They're all placed into different orbits. And you have the satellites there. The satellites are placed. So that it can trace the movement. Right, as what I mean, 32 satellites are there with American GPS. So worldwide, if you look at, what comes here application? Navigation, right? Now, if you look at global position system, so first name comes here, US. What is the name of this? Navstar. Navigation, popularly called US GPS, American GPS. But its actual name is Navigation, Satellite and Ranging. What I've given them, Navstar. NAV stands for Navigation, Satellite and Ranging. That is a part of American GPS, which is followed worldwide. Even India, even though mobile phone, we all use this particular GPS. Then second country is Russia. Now Russia has got GLONASS. You'll come across the name GLONASS, Global Navigation Satellite System. What does GLONASS stand for? Global Navigation Satellite System. This is Russian GPS. So worldwide, two are operable, right? There today, two GPS system is working, that is American GPS or GLONASS. Third has been ready, but not completely been deployed. Which countries come? European countries. And what is the name of European countries? So if you look at European Union, they're in the part of, the name is called Galileo. It has been named Galileo. So what is the name given? Galileo. So Galileo will be fully operational from 2020. कुछ रीजनल एस्पेक्ट में उसको किया गया है, ग्लोबल एस्पेक्ट पूरी तरह से नहीं किया है, ठीक है, लेकिन वो बिल्डअप हो चुका है, इट वाज बिल्डअप. एंड देन आवर हमारे भाई साहब, भाई जो है चाइनीज भाई, राइट, और ब्रदर्स, और चीनी ब्रदर्स, दे आर आल्सो बिल्ड. व्हाट इज द नेम ऑफ दैट? Again, remember that this is the global I am talking about, but now China is building GPS. China presently is having regional GPS, but now China is expanding to make global. We are now working toward regional, but they are now going to global. So the name of their Chinese is called Bidu, B-E-I-D-O-U. Right, Bidu, or Baidu, whatever you pronounce that, the Baidu there, right? And then when China will build the GPS, like global coverage, there is called Compass navigation, Compass. There's Baidu 1 and Baidu 2. Now second Baidu is coming up. So that is just Compass. It's also called a Compass navigation. Just like Compass, you know that, which gives the direction. They have given the name. And it was in the news also, but now they're upgrading. They're making more advanced there. And India, you know that, the fifth country which comes there, India is having IRNSS, and we have named Navik. That is the Navik there. Is regional. So that's what I've given a border. Baidu is a regional, but now China is building GPS. It's not ready. They will make it ready. Very soon, China will be having GPS. They're upgrading that. अभी हम regional बना रहे हैं. हो सकता है कुछ सालों के बाद हमारा भी GPS होगा. We'll also go into that. So that's how these 5 countries comes in the position. Now what is the height? I'll tell you. American GPS satellites have been placed into a height of 11,000 kilometers. So 11,000 kilometers is medium Earth orbit. Now let me provide, since it will be very injustice that we only talk about Americans and Russians and Chinese. We should also think of our own Indians also. So how many satellites we have got? You are aware? Navik has got how many? 7 are there. Now you will understand. Now at that time I have not mentioned those terms. But now if I mention the term, you will understand what exactly the Navik is all about. So if you talk about Navik, has the 7 satellites. We have 7 satellites. I'm now writing very important. Four satellites have been placed into geosynchronous, and 3 are in geostationary, and 3 satellites are in geostationary. Now, can you differentiate now? That is what it said. Now, when you read newspaper about any launch, you will be able to understand these terms. See, geosynchronous can be any height. Did you get that? It can be any angle. I've given that angle here. But when you say geostationary, so what we are referring? We are referring to 36,000 kilometers. So our Navik has got 3 satellites at 36,000 kilometers. So that is meant for what? Communication, because navigation will also require communication. And four satellites are at different angles, and they are what? Medium Earth orbit. They're not into those orbits there, right? Though when you read, you will not be able to figure it out. What is being said in that case? But there is a difference of the term, geosynchronous, geostationary, right? This is what. And I've already said that we can have 1,500 kilometers beyond border also there. The coverage can be beyond borders. We can go up to 1,500 kilometers plus what we have. And what is the resolution? Like you know that when you open your mobile phone, when you're traveling for direction, तो वो जो lady बोलती है ना, take east, take west, and virtual navigation there, that kind of there, take right. कई बार गलियों में घुसा देती है वो. It has happened many times with me. एक बार चंडीगढ़ से, coming from Chandigarh, मुझे पंचकुला वो this I have to take the car there. There's direction given me there which Mohali. I went to Mohali. Then I took the bypass towards the Jammu highway, and then I took a turn and came down to the Ambala camp there. तो कई बार वो कुछ और ऐसा रास्ता बता देती है, तो थोड़ा सावधान रहना चाहिए, right? So what is the resolution there? When you open there, 5 meters, 10 meters, how much it gives? 15-20 meters. And how much is ours? 9-10 meters. Yes, that is it. We are having better resolution than American GPS. It is obvious that we are having near point. But what is the regional one? The regional will be definitely better. Not the global. American is global. So we have 9 to 10 meters. You will get the data on the mobile phone. And once the faulty satellite, which will be replaced this year with IAS 1H, right? Very soon we'll also have Navik app also, right? Once it gets operational, we'll have app also. We can install, mobile phone, Android phone, and we can get the direction there, right? So what is first application? Navigation. What is second application of medium Earth orbit? Apart from GPS there, I've already said what? 36,000 kilometers. So what comes here? Communication. Communication satellites and all this. TV and radio broadcasting. Because this is almost a part of medium Earth orbit. After 36,000 kilometers is a high Earth orbit. Did you get that? After 36,000 kilometers is high Earth orbit. अच्छा, अब मेरा एक सवाल है बहुत, उसके बाद मैं high Earth orbit में आऊँगा मैं. Let me ask a very simple question there. There's something called space debris, space junk, waste material. So where are they? Which orbit? Low Earth orbit, medium Earth orbit, high Earth orbit? Where it is placed? Medium Earth orbit. And also the high and low Earth orbit also. If you remember that movie Gravity, you know that this is falling, which coming from the above there. So what we do, I'll tell you that. All such communication satellites, when they are decommissioned, when they are used up, right? Or sometimes the defective solar panel satellite has all this one. What we do with something called parking orbit, right? No space agency right from beginning has taken the care to bring it back to the Earth or drop it into the oceans. What has been done? Once the satellite placed, after 5 years or 10 years, it is deorbited to a parking orbit. There's something called as graveyard orbit, graveyard. Where is it put up there? Now, first man-made satellite was Sputnik. Sputnik was launched on 4th October, right, 1957. And from then onward, hundreds and hundreds of satellites have been built and placed into the higher, this orbit there. And now it is being threat. why all those kind of debris are lying scattered there in the outer space. And now it has become a problem, and that's why there's already a proposal to clear that debris, right, to clear that part. So what I just wanted to make clear in this kind of concept, medium Earth orbit, where you have this kind of parking orbit, right, where it is placed back and goes into that, ठीक है? लेकिन उसके नीचे भी है, low Earth orbit में भी होता है, जैसे अभी जापान का जो था, what is the name of the, I'm coming to current affairs, what was the name of that mission? Japanese tried but failed, but Japanese will do it again to bring the debris back to the earth. उसका नाम है, there is something name. अब मैंने क्या बताया? Something which is very highlighted current affairs, that year you don't have question. And the next year you have a jhatka, where it is all this space junk and something on that can be asked. So there is something what Japan tried, but Japan was not successful to bring down the space debris. So what is that mission program known as? Which was done by Japanese exploration agency, JAXA. Kunotori. What is the name there? Let me write separately there. Since it has come in this context, I'm just bringing that, Kunotori. Kunotori is basically, in Japanese language, means white stork. Stork, you know, bird. Kunotori name is given. And वो क्या है Kunotori? Japanese वालों ने क्या किया? Japanese JAXA ने, there is something called space ship is there. Basket, dabba. And it carried what? Logistic to ISS. They empty that all logistics. And then they were having this kind of objective. They use a magnetic tether, a kind of tether, like रस्सी जो होता है, to catch, जैसे मछली पकड़ते हैं ना, to catch debris, and then use very high speed, just like this one, the high speed, and pull it to the atmosphere, so that they get burned up in the atmosphere. It's not easy. It's very difficult. It's very difficult to carry out this kind of exercise. That you will put a tether placed into a junk, space junk, and then pull it down to the atmosphere, right? They will not be successful, but maybe Japanese will try again. The next Kunotori will be there, right? So this is what Japanese have done, but space junk. So what is it? Medium Earth orbit, low Earth orbit. They will find parking orbit, which has got all the space junk, used satellite and all this. Now I'm coming to the next one there, high Earth orbit. So now high Earth orbit, any application of high Earth orbit? For what high Earth orbit is used? So high Earth orbit, see most of the application comes in low Earth orbit and medium Earth orbit, right? But there's certain thing which can be done in high Earth orbit. ये सब एक जगह नहीं मिलेगा. I'll tell you that. You just look into that, you will not find in that. That's why today's class become important. You are getting at one place all these concepts, right? Application part. High Earth orbit is anything beyond 36,000 kilometers. So this will come here. What? Beyond 36,000 kilometers. Beyond 36,000 kilometers. Can you think of any application of high Earth orbit? Outer space, okay, that I'll agree. Anything else? What I said in the beginning of the class, if when the satellite is launched, communication satellite is launched, GSAT, it is a highly elliptical orbit. और कल मैंने कुछ बताया था बहुत इंटरेस्टिंग, अगर आपने रिकॉल किया हो, मंगलयान के बारे में कुछ बताया था. What मैंने बताया, geocentric orbit, then झटका was given, captain has sun's orbit, heliocentric orbit, then again was झटका was given to the Mars, right? There's something called transfer orbit. What comes into orbit here? The application part, this comes transfer orbit. What is first thing here? Is a transfer orbit. कई बार इस ऑर्बिट को there is a name also given, Hohmann orbit बोलते हैं. NASA has been using this kind of a concept there. Transfer orbits are temporary orbit. They're not actual orbit. They're only for particular mission is used for certain days and then is removed. Like Mangalyaan, we have used transfer orbit. So what I want to write here, space exploration, right? And anytime if you want to come, just always remember Mangalyaan, how we did that. We put in an elliptical orbit. That was very higher, 40,000 kilometers. That was the part. And then we maneuvered, what is called maneuvering. We maneuvered to the sun's orbit. That's how we have done that. Now what is the second object here? Again, I'm giving very latest information, very important, useful information. There's something called Lagrange's point. Lagrange point. I don't know how many of you are aware. कितने लोगों को पता है? Lagrange's point. रीजन IAS के मटेरियल में भी दिया हुआ है. और हमने अभी कुछ दिन पहले हम लोगों ने कुछ बात की आदित्य, right? So where is the Lagrange? So I'll explain all this, but I'll give you Lagrange's point written part also there. But let me write here. Lagrange's point is there. इसलिए मैंने क्या बताया? Your notes, the class notes, what you are getting today, you have entire information on that at one place, right? These all things are what is scattered, but I'm putting it in a very sequential manner. High Earth orbit, something called Lagrange's orbits or points are there, right? Anyone in the class, जिसको कुछ भी idea हो, ये क्या है Lagrange point, high Earth orbit में, what it comes with that?
Beyond which it will lose the gravity of Earth.
Beyond which it lose the gravity of the Earth, okay? Simple language बताना है. Always remember that. Keep the things in that way so that any layman can understand. Okay, there again I said, UPSC will not ask you any equation, formula, mathematics, but something basic thing you should remember that. क्या है Lagrange point? ऐसा क्या खास है उस points का high Earth orbit में? Sun's gravity and Earth's gravity balances. It is that point in the outer space where Earth's gravity is get balanced by Sun's gravity. So let me write. You can write there. Sun's gravity is balanced by Earth's gravity. Right? Let me write here. Sun's gravity is balanced by Earth's gravity, and there are 5 such points. I'll draw the diagram there. There are 5 such points. Like this. Let's say if this is Sun, this is the Earth. Right? 3 points lies here. Again, remember that though I am giving you all explanation, UPSC will not ask you to write Lagrange's point expression, just only back of the mind. हाँ, लेकिन एक चीज याद रखना है, जब ऐसे words use होंगे एग्जाम में, उस समय that time you should not be in a what is it, Greeks and Romans, Lagrange's point coming there. It should strike back to you. ठीक है, मेरा चेहरा उसमें याद आना चाहिए. That time, something Lagrange point is there. So what are the thing point? Now look at here. One point is here. Second point is just here. And third point is here. Right? There's something called L1, L2, L3. Right? This is L1 point, L2 points, L3 points. And there are 4 points, and 5th point. They are at 60 degree from the Earth. 60 degree angle. You have L4 points and L5 point. What I said, Lagrange point is that point in the outer space where Earth's gravity and Sun's gravity balance. तो इसका मतलब क्या है? It will become stationary. There's only the possibility when you place there, it will become stationary. It will get balanced out there. So it will be basically part of Earth only, but will be balanced there. So what is we are going to have here? This kind of a orbit. NASA is also going to use and ISRO is also going to use. We are going to use the Lagrange's point for Aditya. And what is Aditya meant for? Sun's exploration. So they'll place into high Earth orbit. And I've clearly given what? Space exploration. Right? So here the example which comes here, Aditya spacecraft. And the current aspect में NASA का जो आया है, that is the name. NASA is building a very advanced telescope, and next year it's going to be in Lagrange's point. Can anyone in the classroom name that telescope of NASA? One name I have given there, Hubble, Kepler, but there's going to be another very important telescope of NASA which will use Lagrange's point. What is the name of that telescope? James Webb. What is the name there? I'll write it. So you can write in the class note there. James Webb Space Telescope. ये आपको PT 365 के मटेरियल में मिल जाएगा. करंट अफेयर्स वहाँ पे भी दिया हुआ है. जेम्स वेब स्पेस टेलीस्कोप. Where it will place high Earth orbit, not in the low Earth orbit. जबकि मैंने क्लास में क्या बताया? Most of the astronomical observation happens at low Earth orbit. But we are going to have now new type of orbit, high Earth orbit. That point. Okay? These all things which are given point wise, things you have to remember that. What types of orbits and this thing. Right? यहाँ तक है. Now I'm writing a term here. Kessler syndrome. This has been asked in mains exam. Kessler syndrome. What is Kessler syndrome? Kessler syndrome. What type of disease is this syndrome? Right? Syndrome होता है. Syndrome what we use for normally for what diseases. But it's not a disease. ये बीमारी वगैरह नहीं है. कुछ अलग ही चीज़ है. Yes, हाँ, you use right.
Another thing that this chain will continue and keep on repeating.
ये कहा गया है, what has been said, if any time in the outer space there is a collision, so collision will generate debris, and this debris will result into further more collisions, one after another, right, which will result into more debris. This was called Kessler. Kessler is the name, Donald Kessler of NASA. So it was given by Donald Kessler. Donald Kessler of NASA, he gave this kind of a syndrome is kind of hypothesis. What is said here is that I simply write in one sentence, proliferation of space debris. What is the space here? Proliferation. Proliferation of space debris. In case if there is any kind of a chance collision, right, in the outer space, that will generate those kind of junk or debris which will further lead to cascade of collisions, chain of collisions. And when there will be chain of collisions, there will be more and more debris. So what I have used the word here? Proliferation of space debris. Right? In simple sentence, the proliferation of space debris. That is called Kessler syndrome. Right? So this all now is the coming back to the news. Space junk, space debris. China is trying to develop a satellite too, which will be put in orbit and deorbit also. Now space agencies are developing कि to make ऐसा satellite बनाए कि वहाँ डाले फिर नीचे ले आए, वहाँ छोड़ना नहीं है, तो अब उस पर काम चल रहा है. I have given the class. Japan is trying to pull the space debris back to the Earth. All these are now coming to the newspaper there. Right? Is it clear here up to here? Right? Now let me see that if I'll now go to the certain slides and let's see that if I can play a video or documentary for you people. ठीक है, is all there? Right? All right. See, now you'll be able to connect the things. See, remember that. Sometimes ये होता है कि when I start with science tech, so I always start with development part to go into that. Then I'll slowly fill up the skeleton. Things are there. So that you are aware of all these terms when it comes to the news and all this. इतना तक में आ जाना चाहिए. Right, and wherever possible, if you want to stop me, please stop me is also there. Right, कोई भी है, no doubt is a silly doubt. Every doubt has got something. Right, it has got the weight is there. And class के बाद तो I am always there. ठीक है, इसमें चिंता सोचना नहीं है, ये तो इसको नहीं है. दो लैपटॉप में मैं भी कंफ्यूज हो रहा हूँ. Okay, this laptop is there. खुल गया, right. Open? खुल जा सिम खुल रहा है. It's coming there. Because afternoon time, na? So he's not a meerkat. बड़े अक्षरों में. Now look at here. So now I'm coming to this. So what I explained on the whiteboard with all the points, I have put across here also. ठीक है? You have space, satellite, orbits, and the definition part. The definitions I have given, right? I have also given the photograph also there. Now why it is done? I have given the part. The orbit that is chosen for a satellite depends upon its application. Depends upon its application. Those used for direct broadcast television, for example, use geostationary orbit. right? That part of many communication satellites similarly use a geostationary orbit. Other satellite systems such as those used for satellite phones may use low Earth orbiting system also, satellite phones. And you know, satellite phones are not given everyone. You cannot carry satellite phone there. It's only with the army or security agencies. They use satellite phones. Now what is similarly satellite system used for navigation like Navstar. So now what is Navstar? American GPS. Or global position system occupy a relatively low Earth orbit. Relatively there. So medium Earth orbit 10,000 kilometers, something on that. There are also many other types of satellite, from weather satellites to research satellites, or sometimes scientific research satellites, right? And many other. Each will have its own type of orbit depending upon its application, right? So every application is based on some kind of orbit concept there. Now look at here. The actual satellite orbit that is chosen will depend on factors including its function and the area it is to serve, which area it has to serve. Then what I've given, in some instances, satellite orbit may be as low as 100 miles, 160 kilometers, which will be very, very near to the Earth, right? Or for a low Earth orbit, whereas others may be 22,000 miles, right, which is equal to 36,000 kilometers. So that is a high as in the case of geostationary orbit. The satellite may even have an elliptical rather than a circular orbit. That can also possible. Transfer orbit, that can be considered there. So this is how it looks like. Circular in this one. Perigee, apogee. Right. I have also given a table here. This I mentioned that circular orbit distance from this Earth remains the same at all times. Elliptical orbit, the distance will change. That part is there. Orbital plane I have given there. It is not necessarily always 90 degree or 0 degree. It can be inclined. That part I have given, equatorial plane and the north-south polar plane. This diagram I have given there. Right. So this diagram वहाँ draw नहीं करना है. Exam में कभी आ गया तो वहाँ draw नहीं करना है. It is only for your background information. Right. Now coming to here, so PSLV and GSLV, this part I have given there. But before that, let me see if I can go into certain documentaries. So GSLV Mark III, which came in the news. Right? And what is the GSAT 19 mission there? And let's say YouTube. Videos there.
And developed by the Indian Space Research Organization, and it will double India's capacity of launching satellites while reducing costs. In the making for about a decade and developed at the cost of 2,500 crores, the rocket is a designated space vehicle to ferry Indian astronauts in space. NDTV Science Editor Pallav Bagla reports.
First images of India's latest monster rocket, called the Geosynchronous Satellite Launch Vehicle Mark.
Launch heavier communication satellites.
How does it help somebody on the street?
So the communication satellites are benefiting the common man in the country, number one. And number two, will provide us to do that more efficiently and through the indigenous.
Now an exclusive preview of India's heaviest rocket till date that will also ferry humans in space. An altogether new heavy lift rocket has been designed and developed by the Indian Space Research Organization, and it will double India's capacity of launching satellites while reducing costs. In the making for about a decade and developed at the cost of 2,500 crores, the rocket is the designated space vehicle to ferry Indian astronauts in space. NDTV Science Editor Pallav Bagla reports.
First images of India's latest monster rocket, called the Geosynchronous Satellite Launch Vehicle Mark III. This mock-up version has been readied to test its stability.
GSLV Mark III is intended to launch heavier communication satellites.
How does it help somebody on the street?
So the communication satellites are benefiting the common man in the country, number one. And number two, will provide us to do that more efficiently and through the indigenous capability.
Standing tall on the launch pad, its individual components have been tested, and the first suborbital experimental flight is expected in a year. a flight that will test how the rocket performs in the atmosphere. Its vital statistics are astounding. It weighs about 640 tons. It's over 42 meters tall, or as high as a 17-story building. This is the rocket that will ultimately launch Indian astronauts into space.
Make sure that the reliability is of the order of 0.99. But GSLV Mark III has a capability to put 3 human beings in the crew module that it can carry.
Excitement at the Indian Space Research Organization, where they are getting ready to launch India's heaviest rocket ever, the Geosynchronous Satellite Launch Vehicle Mark III, a 630-ton monster which is equivalent to the weight of more than 125 elephants. In Bangalore, with camera person Nazir, Pallav Bagla for NDTV.
So I had this one, but today I didn't got this pen drive, so that's what I was not. I have to play through YouTube only. Now this is which launch was there.
Drive on.
All
Very
stations
shortly.
stand by for the time mark. Mark means 1 minute and counting.
Minus 1 minute.
This Sri Harikota.
Minus 55 seconds.
All sounds are out.
Minus 50 seconds.
Sequences are out.
Minus 45 seconds. Minus 40 seconds.
Minus 40 seconds.
Open.
Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 30 seconds.
Open.
Roger. Minus 25 seconds.
Alert and VSPP open.
Minus 20 seconds.
Minus 20.
Ignition arms out.
15 seconds.
Cryons are out.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, plus 2,
S200 ignited.
plus 3,
Vehicle liftoff.
plus 4, plus 5, plus 6, plus 7, plus 8, normal, plus 9, plus 10
You
seconds.
just heard the announcement. Liftoff normal.
Before tracking, plus 15 seconds,
15 seconds into the flight.
plus 20 seconds,
S200
first stage performance normal,
indicated as
plus 25
normal.
seconds, plus 30
Vehicle
seconds,
moving majestically.
plus 35 seconds,
Plus 35 seconds. This is a very critical phase. Going atmospheric.
plus 40 seconds,
40 seconds into the flight.
plus 45 seconds,
7 kilometers.
plus 50 seconds,
50 seconds.
first stage performance normal, plus 55 seconds,
First stage performance is indicated normal. So we will
Plus
have
1
in the
minute.
next 50 to 55 seconds the ignition of the L110 liquid engine.
Sharman in main auto.
75
Sharman
seconds.
in main auto.
Vehicle at 18.7 kilometers.
first stage performance normal,
First stage performance normal as indicated by the range operation director.
plus 1 minute 30 seconds,
So 90 seconds into the flight. Another 22 seconds will have the ignition of the L110 stage, which again is a very important activity. And if you look at the plots of the time versus altitude and velocity, we see a very close match with the pre-flight and the flight predictions.
L110 ignited,
Yes, L110
Plus
core
2
booster
minutes.
has been ignited at exactly 114.9 seconds. The vehicle is at an altitude of around 51.5 kilometers.
normal,
And L40 ignition and performance has been indicated normal. हम इस वक्त रॉकेट के पहले चरण के फेज से गुजर रहे हैं, जैसे कि आपने सुना S200 रॉकेट जो जमीन पर इग्नाइट हो गया था.
S200 separated,
Just now we heard the announcement S200 solid stopper has been
First 2 minutes,
successfully
30
separated
seconds.
at 141.2 seconds and vehicle has entered the closed loop guidance in the second phase of flight. So अब तक सॉलिड ईंधन वाले चरणों का परफॉर्मेंस बिल्कुल नॉर्मल था, रॉकेट की ऊंचाई और गति बिल्कुल जैसे विश्लेषण किया गया था उसी तरह से काम करता हुआ। दूसरा चरण L110 स्टेज अभी इग्नाइट हो चुका है और अभी हमने रेंज ऑपरेशन डायरेक्टर से घोषणा सुनी कि यह सही सलामत काम कर रहा है। Right now we are at 180 seconds and the altitude is around 95 kilometers.
L110 performance normal.
And we again heard the announcement of the normal performance of L110 stage. As per the nominal sequence, at 224 seconds, we should have the separation of the heat shield. So we are at 200 seconds, altitude 105 kilometers. And very shortly, we'll hear the announcement of separation of the payload fairing.
L110 performance normal.
L110 stage performance is normal. As far as the range of the vehicle is concerned, it's almost traveled 200 kilometers from the launch base. It's an altitude of around 117 kilometers. And heat shield has been successfully separated at 225.7 seconds. As far as the velocity is concerned, we have almost a 2.5 kilometer velocity has been imparted to the vehicle. The final injection velocity is order of 9.8 kilometer per second. The next important event will be the separation of L110 ton separation, which should happen at 320 seconds. So roughly around 80 seconds to go. As I was mentioning earlier, L110 ton stage uses the Vikas engine, which is being used for L40 stages of GSLV, the liquid strap-on boosters, the second state of GSLV, and the second state of PSLV as well. But the duration here is almost for 200 seconds as against one.
Why is I allowed this to go continuously? Because there are very important words have been said. L110 stages, right? You have seen in the S also there. And just now, a very important word was dropped in, Vikas engine. So that's what it is. Initially I played that. Now I'm coming to all the details. Now you'll understand all this which we said in the video, how has happened. Now, so let's first have what I've said in the classroom, and I'll play the video again. You'll get to see where the cryogenic stage comes, right? Let's first understand this. See, when I said what launch vehicle, see, launch vehicle technology or launch vehicle is that kind of rocket which is used to put payload. So what I'm here is that is a rocket system to place payloads, here the word comes payload, into outer space. For that we develop this kind of launch vehicle technology. Now here, the second main aspect which comes here, it has got about propulsion system. Now, I have already said in the classroom, but again I'll add here the two types of propulsion system on which rocket works. One is that which is conventional rockets. Conventional rocket carries its own kind of oxidizer, right? So one is that what is called here non-air breathing system there. Breathing propulsion system. Now such kind of system, here the rocket carries fuel, and fuel is burned with oxidizer. It uses the fuel is burnt with an oxidizer. And this is what the conventional rocket does. Because conventional rocket has to go to the outer space. There is no atmosphere. So it carries its own kind of oxidizer along with the fuel, right? Now what is second here? Air breathing system. Now air breathing system, not many countries have got this kind of propulsion system. Right, this system is only with US, Russia, China, and now India is the another one to have this kind of a technology in the rocket technology to be used. So there is something process system. So here, what comes here? I'm writing a very important word, scramjet, which I explained the last time there. There comes supersonic combustion ramjet. What is called supersonic combustion ramjet? What is ramjet? It burns the fuel under compression, right, from the air. It takes from the air. So scramjet will only work in terms of the atmospheric part of that. Right? What is I'm saying that? Scramjet is called super compressed, right? Combustion or supersonic, sorry, supersonic combustion, that is a ramjet. Why? What happens here? the air is taken from outside, compressed, and then burn the fuel. And what type of velocity will be? Hypersonic. It gives hypersonic speed. Right? And it happens where? Where atmosphere is there. Outside atmosphere, scramjet will not work. It's only within the atmosphere it will work. ठीक है, तो यहाँ पर क्या है? There is no oxidizer. What is very important is that it carries no oxidizer. Here, there is no use of oxidizer. Right? Oxidizer is not required in this kind of system there. But what is the limitation? It can only work in terms of atmosphere, not in outer space. Right? So what I've said, the two kind of combinations comes there. Now, what I'm coming to here, launch vehicle, the fuel. We have fuel there. Now, fuels are the first type of fuel. What is propulsion system use? The solid fuel. Today, India has reached to a stage where we are self-sufficient to develop all the critical technology, fuel, propulsion, and sometimes it is also called propellant. Propulsion means which gives a thrust, going against the gravity there. The thrust part of this, which can take it further there. Now, propellant here, solid fuel. Now, let me give example. In India, in PSLV and GSLV, both the rockets, we are using solid fuel as HTPB. I'm giving you this information also, HTPB. HTPB stands for hydroxy terminated polybutadiene. This is what is used, right? If any exam, right, UPSC will not ask you so technical chemical formula or chemical name, but in any exam which you appear and there this name comes, right? There's a fuel what we have developed indigenous, and we are using in our both the rockets. Second is what called liquid propulsion or liquid propellant, liquid fuel. And in both PSLV and GSLV, we are using liquid propellant as UDMH. What is the name here? So let me write here the name here, UDMH. The UDMH stands for unsymmetric dimethyl hydrogen. Unsymmetric dimethyl hydrogen. This is the fuel what we are using there. And in India, we have developed an engine, rocket engine named Vikas. Vikas engine is that engine which works on liquid propellant, liquid fuel. And how we burn it? With the help of N2O4, nitrogen tetroxide. Right? So plus it uses what I'm writing here, N2O4, nitrogen tetroxide. Right? And the name of the engine is called Vikas engine. ठीक है, तो किसी एग्जाम में अगर कभी आता है, मैंने क्या बताया कि what UPSC wants? Inquisitiveness in the candidate. See, this is one exam which is faced by students coming from all backgrounds, right? And the students are from commerce background also, humanities background also, or would have studied science till 10th standard or 12th standard. So what UPSC tries to check there is that at least the basic terms, basic things you are aware of it, right? So basic things are this only. If in case comes, and now I'm writing there, this is Vikas engine. This Vikas engine is the engine for PSLV. It was first designed. Remember that? PSLV is the first rocket in India which used liquid propellant along with solid propellant. First time. That's why name Vikas. Vikas name has been given. किसी का नाम विकास है यहाँ पर? It's a common name, na Vikas. Vikas is a common name there, right? This is what comes into that. Is it clear here? Then comes what? Now next one. Apart from propulsion system and fuel, what comes very next, which you have to remember? That is what I'm writing here. That is I'll write on the top here. The next aspect, what comes here? Payload. What payload it has to carry, and that will depend upon applications, right? So here the payload is there. Now what are the payload? Satellites, right? So it includes satellites, right? And along with satellites, sometimes will be here space probes, which has to be put into the orbit, or even humans. That can also be part of the payloads. What you have heard here, crew, right? Crew module, where 3 humans can be there, part of GSLV Mark III, right? Which can be put in the outer space. So those kind of a payload can be there. But mostly it is what? Spacecraft, satellite, right? This part. Now the part which we have, space probe मतलब जैसे मंगलयान है या कोई भी चीज़ स्टडी करने के लिए, probe मतलब होता है स्टडी करना, तो सैटेलाइट ही है मतलब, लेकिन वो नॉर्मली क्या होता है एक्सप्लोरेशन के लिए यूज़ करते हैं, तो इसको प्रोब वर्ड यूज़ करते हैं. प्रोब मतलब कुछ पता करना है, कुछ ढूंढना, वो चीज़ है, ये चीज़. ठीक. नाउ लेट मी डू वन थिंग. I'll come back to the video later on. Let me just close there. Now next what comes here, what do you have to know there? Any launch vehicle technology will also have telemetry, control and command system. What you have seen here in the Sriharikota was getting all the data. It was giving all this. So control and command system. All this gets commands. There is something called separation. It works on such kind of system. And in India, and I'll give you that, in India, we have a very important center called Master Control Facility, MCF, what is called Hassan. Let me write here. So I'm providing the name of the center also. Master Control Facility. We have in Bhopal also there, but this is the important one is Hassan in Karnataka. That is able to control. Once you put the GSAT, then it goes into the hands of Hassan. And Hassan then takes into all, what I said, maneuvering, bringing to the right orbit. Is done there. In Bhopal also we have a regional center for that. This propulsion system, what I said, liquid one. So what is the name of the center here? I have given the name there, LPSC. Where is LPSC located? Mahendragiri, Tamil Nadu. In Mahendragiri, Tamil Nadu, there we have liquid propulsion system center where we have developed this kind of engine, Vikas engine, and the fuel which is made here. So that is the ISRO center. And you know, liquid propulsion system center. There is a place, Mahendragiri in Tamil Nadu. That is where the center works this kind of a fuel there. Liquid propulsion system center. Okay. Now what comes the next one here? Depending upon the utility of the rockets, right? I have said in the classroom that here we have what? Expendable. Right? Launch vehicle. What an expendable launch vehicle? Can be used only for one missions. Only once for a space mission. These are called expendable launch vehicle. We cannot use it again and again. This part I have already said in the classroom. And second, what comes here is reusable. RLV there. Right. And reusable launch vehicle. Now I'll give you one very important concept. First, let me write. Can be used several times for different missions there. Now understand here. Reusable launch vehicle can be both manned and unmanned. It's a very important point I'm bringing there. It can be unmanned also. It's not necessary that we have to always put humans to and bring it back. And it can also be manned. Now imagine if India develops RLV, we will save a lot of money. Because today, whatever PSLV, GSLV using, we use and it is consumed. Again, we have to build. It adds cost. Right? Now imagine that we have got such a rocket where we can put satellites and come back and be prepared for next satellite launch. At the same time, we have that kind of a reusable launch vehicle which can put more payload, heavy. So we will have two advantages. One is that cost will earn a lot of money. And second is that India will open a big market where will give a tough competition to SpaceX. And even NASA and all those countries can ask India to take logistics to ISS and bring it back, RLV. RLV can do that. We take logistics and come back. So India is looking for that particular space in the market. Right? That place India is looking for that. That's why this technology is going to be a game changer for India's space program. But at the same time, we can also put a human astronaut and bring them back. So both purposes there. Generally, जो RLV का जो आता है तो लोग सोचते हैं केवल manned spacecraft. It can be for that. और उसके भी scramjet काम आएगा. We'll be using scramjet for that. We are developing for that, right? Now I'm coming to, if you have written this one, then I'll remove this. Is all you have written this one? So now I'm coming to difference between PSLV and GSLV. And why, for what object has been made there. I'm now coming to the basic stats about PSL, GSL. Simple is that rocket will have one fuel tank, another will be oxidizer tank. And they'll burn the fuel to generate the gas, thrust. It's called non-air. That means, non-air means it doesn't take air from outside. Oxygen उसके बाद already है, ठीक है? Air breathing में क्या होता है? It takes air from outside. Your simple nozzle. It takes air, burns there, and the gas comes out. Generally, it happens with fighter craft or let's say missiles. These are called ramjet, scramjet. But it can be in the rocket also there, rocket technology. So now let me come to that part. I'll just remove this one. Next point is what is that? I'll put up in a tabular form. I'll come to that tabular form. You'll understand what are merits and demerits and what type of configuration we have got there. Different configuration we have. So I'll bring about all those important facts also there about PSLV and GSLV. So now let's understand here. When we talk about here, Polar Satellite Launch Vehicle and GSLV. Now GSLV stands for not geostationary, geosynchronous. That's why I explained the word geosynchronous means, geosynchronous satellite launch vehicle. Now, Polar Satellite Launch Vehicle, the first thing is that it is a 4 stages rocket there or launch vehicle, right? So when we look at PSLV on the launch pad, it somewhat looks in this kind of a configuration. On the launch pad, it looks into, is a 42-meter tall kind of rocket there, right? First stage, I'll draw the diagram. The first stage, what you find is a solid fuel. It burns solid fuel. First stage is always counted from the bottom because as the rocket lift off, the first will get burned or detached. Then second stage, then third stage, fourth stage. Now second stage is what called Vikas engine. There is a liquid fuel. Then after it's burn out, separates. Then third is ignited, that is called solid again there. And then again you come across here liquid. This is what I'm saying about 4 stages. And where is the payload? Payload is here. Satellites and all are placed here. All these are kept at the top. This is how it burns there. Right? Whereas GSLV is 3 stage, which I've already said in the classroom, 3 stages rocket there. Right? 3 stages. Payload means something which is carries their instruments and satellites there. That is part of there. Now, on the other hand, GSLV is 3 stage rocket, and again it is a very heavy rocket. It is not a light rocket, and even heavier than PSLV. So there, if you look at the launch pad, so it looks like a kind of a configuration which has been built there is more bigger, width-wise is also more. And there, if you look at this one, so this has got first stage called solid, similar to PSLV. Is the first stage works the solid fuel. Second stage is similar to Vikas engine, what is called liquid. And this is what you all know is the upper stage, third stage, cryogenics. Now what is cryogenic? Here the liquefied liquid hydrogen, right, burns with liquefied oxygen. Now liquefied hydrogen is at what temperature? 20 Kelvin. How much is 0 Kelvin? Minus 273.16 degrees Celsius. So when you say 20 Kelvin, that is comes to minus 253 degrees Celsius. At such low temperature, extremely low temperature, it is stored. Hydrogen is stored. And then I have written here liquid oxygen. That is a 90 Kelvin. Stored at liquefied temperature, that is a 90 Kelvin. Minus 183 degrees Celsius there. Is burned there. The 2 tanks are the burnt. And generate the thrust, the upthrust there. So that what comes here. So cryogenic engine, why we are preferring cryogenic engine? Because what is the advantage here? Then I'll come back to the table there. The first is that efficiency.
Long time.
Right, efficiency, long time, and it is a highly efficient rocket engine. Efficiency part comes there. Second is that in terms of the calorific value, the heat energy which is there. The high calorific, that means energy content. So it can generate more thrust, high thrust. And third aspect which comes here is a clean fuel. It will not generate any kind of toxic, noxious gases. You know, water there, H will burn there. And what is fourth thing? UDMH, STPB or all limited chemical synthesis. Hydrogen is abundant in nature. Universe is full of hydrogen. So what is here? Renewable. Right, in terms of the cost factor also. Cost efficient, because we don't have to spend more money in terms of the making of this engine there. The engine is the fuel part. The cost efficiency also comes. So cost part of that. Now I'm coming to the next one in the table. The second point is that what I've said here, I have drawn the diagram. So I'm writing here, uses solid, liquid, solid and liquid propellants. Here, as I said here, uses solid and liquid propellant in first two stages, or fuel there, propellants, and cryogenic in upper stage. This is what you find, the upper stage there. Last stage it comes there. Now, third very important point. Third point is that PSLV was developed to put satellite into polar orbit. The word is what? Polar. It was meant to put a heavier satellite into low Earth orbit, polar orbit. But we are also able to use PSLV to launch communication satellite into geosynchronous transfer orbit. So what is very important point I'm writing here? Primarily, here is it is meant for what? Primarily, when it was developed, meant to place satellites or spacecraft in low Earth orbit, polar orbit there. And GSLV, geosynchronous. So what is primarily it is meant to develop? Was there primarily meant to put into geostationary orbit or geosynchronous orbit. Primarily meant to place satellite or spacecraft in high Earth orbit, in geosynchronous, I'll use a simple word, geosynchronous transfer orbit. I'll give another very important fact here. What is transfer orbit? Just an elliptical orbit. Now what is the next point? You remember that. What I've said, polar orbit. But PSLV also puts into geosynchronous transfer orbit. Now I'm giving the fact. How much? 1,750 kilograms. And that not the normal version of PSLV. I'll be coming to that. So PSLV can place, what I'm writing here, can place 1,750 kilogram satellites. Those people who cannot see at the back, I'm reading also, into what I've written here, GTO, geosynchronous transfer orbit. So it can place, I'll read out there. What I've written, fourth point, PSLV is capable also to place 1750 or 1800 kilogram, right, communication satellite into geosynchronous transfer orbit. But let's say 2200 kilogram, 2500 kilogram, PSLV will not be able to do that. That is the limitation of PSLV. Right? There we require GSLV. So GSLV can go for 2-ton heavier satellites. So what the next point is that can place heavier communication satellite. Heavier satellites up to 4 tons. I am writing here 4 tons into GTO. What is the fourth point there? Can place heavier satellites up to 4 tons, like GSLV Mark III can place 4,000 kilogram weight of satellites there. That is capability. PSLV cannot do that. Even the advanced version of PSLV cannot do that. Okay? And now I'm coming to the last point, fifth point here, is that PSLV has got 3 versions. I've said the versions, no? It has got 3 versions. Can you name the versions? Which are the versions? One is called standard version. PSLV I'm talking about. Core, standard, XL, extra large. Right? It's got 3 versions. What is this name? The first is called core. Second is called standard. And third is called extra large. The 3 versions of PSLV. Core version, standard version, extra large version. Right? And GSLV has got again 3 versions. What is the name of the 3 versions? And here we use what? Mark 1, Mark 2, Mark 3. That is what comes there. So here again you have 3 versions. But again in terms of capability of carrying there, it comes into that. Mark 1, Mark 2 and Mark 3. The heaviest one is Mark 3. क्या डिफरेंस है इसमें? जब ये जो वर्ड यूज होता है एक्स्ट्रा लार्ज, स्टैंडर्ड, क्या डिफरेंस है? पेलोड तो है, वो तो चीज़ है. एक और डिफरेंस है, बूस्टर रॉकेट. व्हाट इज द कंसेप्ट हियर? बूस्टर. एक्स्ट्रा लार्ज में बूस्टर्स होते हैं. कहाँ होता है? फर्स्ट स्टेज में, राइट? सो यू कैन राइट देयर एक्स्ट्रा लार्ज. हाउ मेनी बूस्टर्स आर देयर? 6 boosters. How many places? 6 boosters are there. 6. अब मैं यहाँ पे लिख रहा हूँ, क्या है? सॉलिड है, लिक्विड है? सॉलिड बूस्टर. कर 6 solid fuel, solid boosters are there. And now I'll draw the diagram. This is diagram there. When you look at extra large, ऐसा होता है यहाँ पर. This is strapped होता है यहाँ पर. इसको कहीं बोलते हैं strap on बोलते हैं, strap on. 6 fuel tanks are there. Then we'll be able to do it what? Heavier. They are called booster rocket strap-ons. Let me write here. What called strap? STRAP strap-ons. उसमें fuel होता है. You can understand. They're like tiny rockets. Right? Why initial stage वहाँ क्यों लगाते हैं? हाँ, remember that. When the rocket is on the launch pad, it is very, very heavy. It has to carry entire weight. All the engines, all the parts is very, very heavy. At that time requires more energy. As it gets detached, it becomes lighter. Right? So initially requires more energy, more thrust. That's it. Now I'm coming to GSLV. GSLV you have seen in the video. GSLV also carries booster, but there's difference. Right? You have seen Mark 3 has got a very important, you have seen that 2. What is it? L110. What is it? Liquid 110. What is 110? Is the amount of the fuel. 110 is tons of the fuel which has got burnt out. So what happens here? Normal Mark 1 or Mark 2 contains 4 strap-ons. A बहुत important point में बता रहा हूँ. Mark 1 and Mark 2, when you find there, it carries here 4. Again, very important difference. There I mentioned what? Solid. What type of? There is a liquid. Liquid boosters are there. Strap-ons. And how does the Mark 3 look? A central part and 2 boosters will be the bigger size. Right? And Mark 3, if you look at Mark 3, it has got 2 heavier boosters are there. Right? Mark 3 में 2 बड़े, almost looks like mini rockets, which are burnt there. And what was said there? It is similar to what called Vikas engine. What actually the Vikas engine has got. It's similar to that booster is there. Right? That's why it is able to carry heavier 4,000 kilogram size of satellite or payload there. Right? So normally when you read book, we'll give you all this information, but it's not that updated book. Right? Right? So here, this all information you will only get from the ISRO website. When you read in detail of that, you will get to understand these are the main aspects. Right? So if a question comes in the exam, at least you will not fail. You will be able to solve this. Is it clear? I have given all the 5 main points about all PSLV and GSLV. Development part I have already said 1993, 2001. ठीक है? उसमें हुआ था हाँ. Yes. नहीं, कोर में कुछ नहीं होता है. स्टैंडर्ड में होता है, मैं बता रहा हूँ, स्टैंडर्ड में भी यूज करते हैं, लेकिन उतना हेवियर नहीं होता है. कोर में कोई बूस्टर नहीं हो. कोर जो होगा सिंपल प्लेन होगा वो. ठीक है, जहां हमें यूज नहीं करना होता है. तो कई बार जो PSLV एक्स्ट्रा लार्ज है वो 2000 किलोग्राम से ऊपर भी कैरी कर सकता है, एक्स्ट्रा लार्ज वर्जन. एंड वी हैव डन रिसेंटली. कब हमने किया था? 103 सैटेलाइट्स. जो 100 इंडिया हैज सेट गिनीज बुक ऑफ वर्ल्ड रिकॉर्ड of launching 104 satellite, 104, and that was the extra large, right? Extra large version was there, right? First extra large version was Chandrayaan 1. Chandrayaan 1, 2008, November 2008. That is the first extra large version we have carried out there. So when there is need, so that's what I said. PSLV is still our choice. We are working on GSLV, but still we are going PSLV. And how much the government of India has approved? We are going to have PSLV 50 launches. So अभी तक 39 तक हुआ है. We still have 11 more launches to come. Right? It will go for next 1 or 2 years more. क्वेश्चन बना देंगे. तो 1-2 launches और अभी 2 साल तक चलेगा वहाँ पर. Government has given approval कि no 50 launches तक करना है. तो PSLV will continue there. Meanwhile now we are developing GSLV also there. Right? ठीक है? तो ये चीज़ है. ये basic concept को ध्यान रखना है. what I put across there. All right. Now let me move to the next part of it, and then I'll come to the what has been launches in the past, and that part I have already put in a soft copy. You have already in your student portal there, right? So let me go into that. या वो वीडियो मैं पूरा प्ले कर देता हूँ, the remaining part of it. ठीक है, ये मिटा दूँ मैं? Let me, हाँ, right. Learning in the classroom. If you learn in the classroom, your things are done there. तो वही होता है ना, एग्जाम के दिन कई बार फ़ोन आ जाते हैं मेरे पास, मैं बोलता सर आपकी याद आ रही है, तो फिर मैं ये लैपटॉप खोल रहा हूँ. 2 laps of confusion there. That video, I will play more videos, don't worry. Every area the videos will come there. You'll understand what is ballistic, what is cruise, what you'll get understand there. If you learn everything here, things are done there, right? And I pray to God that such kind of
145 to 150.
Such questions comes in the exam, and you are benefited there, right? You get to all those kind of questions there. आया? हाँ, आ गया. Where is that? ये थोड़ा सा इसको भी हटाना है. I have to remove this also. ये मूवी इफेक्ट नहीं होता है, यहाँ सिनेमा हॉल का इफेक्ट होना चाहिए थोड़ा. लाइट वाइट. In one of the batch, I'll tell you that I don't know which batch, RB1 or 2. I have played about the Mangalyaan. All the story behind Mangalyaan, how it was done and all everything. So let me see now.
50 seconds being used for the
L110 performance normal.
So L110 ton stage performance is indicated as normal. 3.5 kilometer per second, range of around 410, and very close match of the altitude and the velocity as a function of time during the S200 and L110 phase of flight. So 320 seconds, we should hear the announcement of the separation of the L110. After which, yes, L110 tons has been successfully separated, and 318.6 seconds. And C25 ignition has been confirmed. That
what is it? 2 of them are there. GSL Mark 3, you have seen that. S200 solid, that's the first part. It goes into ignition. L10, then it goes into that, and you have second one. And what if I C25? That stands for cryogenic. After solid and liquid, next will be what? Cryogenic. That goes into that.
325.4 seconds. So C25 ignition has been confirmed.
Pre-ignition confirmed, performance normal.
And the C25 ignition and performance of the C25 engine is confirmed as nominal. So we are at 350 kilometers, velocity of 4,
performance normal,
and range of almost 633. So this is a very important announcement of successful ignition of the cryogenic engine for the first time in the flight, and the performance being indicated as absolutely nominal for this mission. As you are aware, in the GSLV Mark III, the earlier flight which was done in December 2014, we had only the S200 and L110 stage and the passive C25 stage. So this is the first flight where the active cryogenic stage is being flown for the first time. And just now we heard the announcement, the C25 performance is normal. So we'll have a burn time of almost 600 plus seconds into this flight. As per the nominal sequence, we should have the C25 shutoff command being issued at 964 seconds. We are roughly around 400 seconds into the flight. 4.3 kilometers. In fact, if you look at the velocity that is being delivered by the cryogenic stage during these 650 seconds of burning, almost 50% of the velocity required for the for injecting the satellite GSAT-19 into a G2 orbit will be imparted by this very important cryogenic stage. This is C25 is the heaviest cryogenic stage ever built by ISRO so far. If you may recall, for the GSLV, we have used a 12.5 ton of cryogenic engine with a thrust of only around 7.5 ton. However, this particular engine, which uses almost 28 tons of propellant, generates a thrust of nearly 18 to 20 tons. So look at the flight parameters. A very close match with the what you're seeing on the bottom of the screen is the altitude plot. The red one is the pre-flight prediction, and the dot
Cryo
Dotted
stage
one is the
performance
one where the
normal.
vehicle is presently flying. So all time versus altitude, time versus velocity, a very close match. 4.6 kilometer per second. This is a view of the launch control center.
Plus 8 minutes.
So another 5 kilometer per second velocity needs to be imparted. The actual velocity at the time of cryogenic shutoff should be 9.8 kilometer per second relative velocity. There's a continuous increase in the velocity during the C25 stage. 510 seconds into the flight, velocity around 4.9, and the vehicle has a downrange of 1,330 kilometers, and it has reached an altitude around 233 kilometers now. Another 200 seconds to go nearly. I think as we go through the cryogenic stage of flight, I would just like to highlight the communication satellite, GSAT-19, which is being flown on this mission now.
Minutes.
So GSAT-19 communication satellite is configured around ISRO standard I3K bus.
Cryo stage performance normal.
And we are at an apogee of around 25,000 kilometers. Maybe another 30 seconds to go. 9:44 seconds.
Cryo engine shut off.
So C25 engine shut off command has been issued at 9:45. The vehicle is at an altitude of almost apogee of 35,000 by 170.
Minutes.
And the GSAT-19 has been successfully separated. Just now we heard the announcement, GSAT-19 communication satellite has been successfully separated. So GSAT-19 satellite has been successfully separated at 960.8 seconds. So GSLV Mark 3 रॉकेट ने अपनी पहली उड़ान में GSAT-19 उपग्रह को सफलतापूर्वक अपने निर्धारित परिक्रमा में इंजेक्ट कर दिया है और मिशन कंट्रोल सेंटर में इधर खुशी का माहौल सभी वैज्ञानिकों के बीच। और आप जो आपके स्क्रीन पर देख रहे हैं वो वन ऑफ द सैटेलाइट सेपरेशन इवेंट्स। इस सारे प्रसारण तक हम आपके साथ बने रहे, इसके लिए हम आपके आभारी। और आए चले हम आपको सीधे मिशन कंट्रोल ले चलते हैं जहां पर इसरो के चेयरमैन श्री किरण कुमार जी हम सबको संबोधित करेंगे। नमस्कार, जय हिंद।
So first one was PSLV C36 when 104 satellite launch when we carried out. At that time we started using this camera, and one by one we can even see that even the separation is proper or not. So GSAT-19 is a very heavier satellite. Now let's come to the part of that. Now what I want to bring about in this classroom there. See satellites when we talk about, and I have already opened that one. Now this is the thing. This is what I have explained here in the classroom. I have put in the slide. So now you can see two boosters are there. GSLV Mark 3. Right? So now if you look at here. So this is what I have given here. Now if you can compare the size also there. 12-story building, and I have given the vehicle weight also there. So GSLV Mark 3 is equal to 8 ambassador car. Right? No, 525 ambassador car. Payload is the 8 ambassador car. This is what the weight is there. Now look at it. This is the PSLV, what I have explained in the classroom. Red color, what you see, the liquid system. And how many you have? The 6 strap-on. Right? This is a 6 small strap-on booster rockets are there. Then GSLV is like this one. I have given the photograph there. Now what you see is GSLV Mark 2. What I said, Mark 2 has got 4 booster. Right? Strap-on there. That part is there. And you already have seen what is GSLV Mark 3. Why I'll tell you that? The basic thing, very, very small thing, you should remember it. Right? Other candidates will not be able to know this kind of things, and they will, if a question comes in case, and you ask in that tricky manner, at least will be able to understand. Now what is this? This is what I've explained, RLV. What is resolution? First it has a booster. You have a booster like a rocket. And on that you have a aeroplane or jet plane. So this is what was done with the ISRO last year, what you call RLV TD. Reusers Launch Vehicle Technology Demonstrator. So what you find here, this is the part of booster. Attached, this is the vehicle which can carry humans. So it is taken and the removed. This booster is removed, separation. And it was based on the hydrogen, you can say S9. S means solid, 9 means 9 ton. When you're taking 100 ton, the 1 ton is 1000 kilogram. That is size, there's the amount of fuel. And what you find here, this is goes there and then it re-enter, came back. Right? And later phase, what will happen there? This type of plane, what we are making, will land on the runway. Well, when it comes to re-entry happens there. This is how we are planning to for that. And this was done in the Bay of Bengal. Now look at this satellite here. Any satellite you'll find, there are few important parts. One is that it's a battery and power backup is there. And that is happened through a solar panel. You have a solar panel. Then you'll also find there's something called transponders. Transponder stands for transmitter and receiver. Right? I'll be now coming to a concept of frequency band. So what happens? What is the role of satellite? To receive the signal from the ground station and then relay it back to the ground there, if there's a communication part. So what generally does is that it receives in one frequency and then amplify, increases that frequency. And that through that signal again returns back to the earth. Right? So there's something called transponder. You'll come across in the newspaper this word transponders will be there, which basically means transmitter and receiver. You have a transmitter and receiver there. So this transmitter receiver works on a frequency range. It works on a frequency band, frequency range is there. And different frequency range has been designated for various applications. That depends on the application part. Right? So एक जो broadcasting या communication होता है terrestrial होता है ionosphere. But this is where talking about outer space and coming back. Right? And here the frequency is not normal frequency like radio frequency and all is there. Ultra high frequency, very high frequency, what called VHF, what we use today, right? Today in our homes we have DTH, direct to home, Videocon, D2H, खुशियों की छतरी, Tata Sky, इसको लगा लिया तो live झिंगा लाला. All this they are based on satellite communication. This broadcasting happens. Now look at here. This is what ground segment you have. Now this is the band, frequency band. But let me come to the real aspect. This one. So just remember that this is what I put across. L band is 1.4 to 1.6 gigahertz. I've already given there your slides there, but at the same time, if you want to write there, you write. So what I've written here, mobile satellite service. Today the wireless communication, initial part, right? Initially, the 1G and those kind of things. So that is in terms of having the part of L band, right? 1.6 gigahertz. Then comes S band, N band. It has come in the news also. S band is sometimes called satellite band. And what is the range here? 2.2 to 2.6 gigahertz. But if you can see the application, digital audio radio service. Digital audio radio service is not a normal civilian service. Right? Normal what we use a mobile phone. That comes as L band. But it is for dedicated for security agencies. Right? Satellite application. And there was one case. What was that case there? This S band, there was something in the news. Antrix has entered into agreement with Devas Multimedia, and the matter went to International Court of Justice also. The matter was raised. Right? What was the this is the case here? This is the Antrix. This is the current affairs I am talking about. This is Devas Multimedia. This in terms of what? Allocation of S band. And it happened when 2008, during the time of G. Madhavan Nair as the ISRO chief. This agreement was done by the government. The question was that how come so strategic, S means strategic. How come so strategic frequency band was allocated to a private company? Right? Then when the matter came to the media, all this is highlighted. Then ISRO withdrew from this agreement. Then in that case, Devas filed a case. Okay, how come the government can go back? Or what the earlier government has agreed to give that frequency band. Right? The matter went to the Court of Justice, and how we settled the matter? By paying huge amount of money to Devas. केस को हमने दबाया क्योंकि इसरो का काफ़ी इसमें ये जो छवि है इमेज was at stake, and we paid a lot of money to Devas. You know, sometimes when matter goes to court of law, the company asks for that all the loss compensation. कि आप compensation आप pay करो आप. So this one issue was there. So what is very important? S band is for digital audio radio services, DIRS. These are used for strategic reason, not for civilian use. Right? Then what I am coming here? C band. This will find most of it. C band is 4 to 7 gigahertz fixed satellite service shared with terrestrial. बहुत इंपॉर्टेंट वर्ड है, इसको समझना है. Fixed satellite service with the terrestrial one. So what we have terrestrial one? Doordarshan, All India Radio, all we are having there. So we have two types of things. Let me draw a diagram. If this is the ionosphere, so one communication, let's say in a house, so we have this chhatri, right, where we use that, right? So one way we are getting signal from the, let's say here, you have a station here, which relays the signal, right? You have radar and all this system is there, which sends the signal. Now one happens terrestrial, what is there here? Ionosphere. And second, it happens through satellites. Did you get this? Earlier television channel relay of signal used to be the terrestrial based, ionosphere based. But now with the advancement of satellite technology, we are having this kind of, and which satellite we are using? GSAT, system of satellite. So what is where the C-band is being used? Both the service. We will have fixed satellite also, along with, joined with this part, terrestrial. This is the terrestrial system there. मैं बताइए आपका घर है, होम है, ठीक है? तो कई बार जो टीवी चैनल वाले जो हैं वो आपको डायरेक्ट भी रिले कर सकता है. आइनोस्फीयर से आपके पास घर पे आ रहा है टीवी चैनल, जो एंटीना होता है, the antenna just catches there. At the same time, this can also be, this TV channel can also send to the satellite and can come to you. So both the things can be operated simultaneously. This is what I'm saying there, right? Because कुछ place में satellite will not be possible, so they will use what? Terrestrial, right? And few places satellite will be possible, so it can be done conjunction, both the system. So for that the C-band is there, and today we are using C-band. This is being used by, in terms of broadcasting, we are using that. Fixed satellite is position, whatever satellite is, GSAT 5 or 6 or 7, the range there. For that particular satellite, the range frequency band will be fixed. And within that frequency band, the signals will be, the channels will run. You cannot move across it, that's part of there. Now, what is here? X band. Now, fixed satellite service, and then what is going? Government exclusive use. This can be done only for the government purpose, not for civilian. Hotline, that is very good. He has given very good one. Hotline, which is totally encrypted. Right, there others will not be, because it will only be for government use. Right, no other kind of civilian use is not there. Then comes what? GSAT 19, GSAT 17 has all got KU band. Right, we have today Kappa band or KU band. Now what is KU band? We have two types. One is 11.7 to 14.5, and the what you find next was extended KU band. कई बार आप पढ़ेंगे KU band and extended KU band. The extended KU band is 12.2 to 18.8 gigahertz, and that is again you can see that. Now see here, KU band normal here FSS, fixed satellite service, broadband services not shared with terrestrial. We don't share there. And the extended KU band will be shared with the DTH. So today our DTH works with extended KU band. That KU band comes into the extended KU band what we use. And how much is the highest range? 18.8 gigahertz, ultra high frequency. And that's what you know that today we are able to see thousands of channels. लेकिन एक चीज़ है, क्या चीज़ है? When there is a clouds are there, cloudy weather, then all it doesn't work. Why it doesn't work? Interruption. Why? Today sometimes we are using what? Terrestrial. Where the problem happens? Terrestrial aspect. Because sometimes the signal can be attenuated because of clouds. And from where the signal is coming? From outer space. Clouds are where? Stratosphere. That again, that's the frequency range becomes very important there, right? And then what you have the last, not shared with terrestrial KA band. You'll find your KA band. That is what our service is not shared with the normal aspect of there. There's again the absence broadband is the KA band. So today we are having KU and KA band. C band you will always come with GSAT, C band, KA band or KU band will be given on that. Right, broadcasting and all this will come. Okay? So this I have put in the slide also there, just to make you understand, because this is one area where question has not come in the exam. It could be one of the area of the UPSC exam, right? So if you are okay, then I'll move to the next one. What I've done now in the slides, that I have given all the application part. एक समय था जब टेलीविजन चैनल में न्यूज़ रीडर यूज टू कम, और आज का मौसम समय समय पर यहाँ बारिश होगी, वहाँ वो क्लाउड है. Now it is not there. What happens now? Indigo. Indigo flies, Mahindra tractor, and then it goes into all the place, cloud and the temperature, right? Because now we have become more advanced. KU band, K band, all the digital aspect has come, right? But this is what the data actually is obtained, right? Actually is obtained data is like this, but then we made it into terms of services, right? So what is called here? Meteorological services, agro-meteorological, sometimes linked with agriculture, right? Like rainfall, and all this will come into that. Then I have given here this Earth observation. You can see the houses, and I'll give you one very good example. Bhuvan. There's a platform called Bhuvan. Google Earth. Similar to Google Earth, we have Bhuvan. And
Not doing anything out of India.
not from there. Sensitive area, no? They would have blocked there. People should not see. Why? Because there's the issue of where Doklam lies there, whether India or China. That is the problem there. You will not be able to get Google Earth. Google Earth, you try. Google Earth is showing there, Doklam.
I've got the application also, but it's not.
Not showing there. No, Google Earth. Google Earth is showing. Google Earth is showing there, but not in Indian code. So, but it is a Bhuvan is also a platform there, just similar to Google Earth. What is right there? That he has an app of Bhuvan. You can also install Bhuvan app, and there you can see those aerial view. Aerial view is there. But now it said Doklam is not being seen there. Block kar diya. Not to see by the no supervision there. Right? So now what I want to say, Bhuvan. See, Bhuvan platform is also very important for administration. And today department ministries are using Bhuvan platform. So what do you have here? 2D and 3D, right? Images. You will have all the aerial views and all this. You will be able to see, right? And exactly right there. As I said, Google Earth. You can look out for your house. Where is your house there? This building can be seen there. So that is what comes here. What? Remote sensing. We are using Earth observation satellite, right? So you get this kind of a photograph, and now resolution has improved a lot. You can get to the real kind of thing there. Then if you look at here, whatever satellite communication, very interesting photograph. Right? DTH. In the house, Gramin Ilake, village. Village there also has this kind of system there. You have TV and radio, TV broadcasting there. India is rising, no? We are having this part of that. So near a Jhopli you'll find it. Now, telemedicine. I have said in the classroom there. Now you can see here 4 photographs. Can you make it out there, 4 photographs? This one. One is what you find, mobile van. And you can see that dish antenna. Just like that. Not refugee camp. It can be used for that. Refugee camp can also be used, but these are for disaster or healthcare part, normal camp there. Rehabilitation part of that. So there you, disaster use more better. Now what you find here, the system there. So doctor can see through video conferencing. It can happen through video conferencing there. And one of the things is, Motiabind, cataract. Cataract and all this been today, telemedicine, Tamil Nadu. In Tamil Nadu, the doctors are doing that. Telemedicine systems are there. First telemedicine system was used in Karnataka, because ISRO and they set up there. Then Tamil Nadu and southern states. Now you have tele-education. So now, bas, मैंने tie नहीं लगाया. Normally the professor, the college and all. Tie and covered with a briefcase also. अब समझ नहीं आया briefcase में होता क्या है. मुझे नहीं कुछ lecturers हैं यहाँ coaching student में वो briefcase carry करते हैं. I've seen that there's earlier type of thing, but new type doesn't happen. New type laptop and Apple and all those things comes there, right? So you have this point. Now it's a teaching part. Now see, very very important one. This school children. What you see the photograph there. The school children learning in the, and they have this kind of what you have a screen and all. So अभी वो देख रहे होंगे वहाँ पर cameras also they live streaming. What is happening in the classroom is also the tele-education, right? So it is for various. But here we are talking in terms of education sector. That part of that. Then disaster management, eye of the cyclone. We can today 100%. We have developed such a good system of cyclone forecasting warning that timely the warning is relayed to the coastal community, and we can monitor the what is called movement of the cyclone and the landfall, and exact time can be given there. So it has been done for Hudhud, Filin, all this has been done there, right? Indian Ocean part, Bay of Bengal. So we have 4 times occurrence of cyclones, tropical cyclone, Bay of Bengal, and 1 time in Arabian Sea, 4:1 ratio. So today India has developed, IMD comes into that, Indian Meteorological Department. It gives into that. Why? Thanks to ISRO. This all satellite system has been developed. Then you come across here, the photograph, this agriculture yield and soil. I have given the photograph in the slide. Then you have cartography. This is what called landscape mapping. Right? Hilly areas, plain areas, all this mapping can be done there. So Cartosat, and again remember that Cartosat is becoming more and more important. Why? Because now we are having more and more Cartosat into that. Then ocean meteorology, coral reef ecosystem, coral reef areas, right? Rural development. Why? Give me example how the application of rural development, satellite application. क्या क्या कर सकते हैं? Using satellite, what we can do in rural development? Cattle rearing program, then agro-meteorological program, right? Even the mandi prices of the crops, right? And this all can be related to the farmers, and they can get all this data there. Even the, what I've said, cartography, the mapping part. Let's say, for example, you are a block development officer, or as initially joining as SDM, sub-divisional magistrate, and you want the certain areas to develop in the village. So what you can have data like this one. You can think that where you can promote more agriculture, horticulture. So this scientific data can help. इसलिए IAS के लिए ये सब जानना जरूरी है. All this you require there, whether you come from any background, right? This is a basic thing you have to know that. Urban development. Now I'll say sprawling, like sometimes jhuggi jhopdi, and the development part of the sprawl of the urban areas. Again, what Bhuvan can get. Where do we want to have the infrastructure created? Right? Where we want the metro train to go? All this kind of maps and things can be done through satellite. This is what comes into that, right? So here I have given the forest cover, and Forest Survey of India. Did you have geography and forest and all? So today we are able to acquire data on different types and classification of forests. Satellite comes into that. And one is what? Ground level assessment, right? इसमें एक और चीज मैं ऐड करना चाहूँगा, forest fire, right? Mapping of forest fires. One is the forest studies, but also you have mapping of forest fire. Then what I've given here, satellite aided search and rescue, right? Where will come disaster management support system. There comes satellite. और इसमें एक बहुत important नाम आता है, वो नाम आता है INSAT 3DR, satellite aided search and rescue, which will help in the disaster management support. INSAT 3D and 3DR. And what you find now, what I'm coming to the last on the slide, is what you see the Gagan. This is how the Gagan has been developed. Gagan uses 3 types of GSAT satellites, what you see in the diagram there. Now what is the full form of Gagan? Okay, ठीक है, let me write here. Gagan stands for GPS aided geo augmented navigation satellite system. Now where we are using this satellite system? For what purpose it has been developed? Gagan system. It is there in the news for the last 2 years. It has come in the newspaper. Gagan system. So where it comes into that? Airports, Airport Authority of India, AAI, right? Of India and ISRO together is a collaboration of 2 bodies there, ISRO and AAI. So where is the main aspect? Civil aviation. It is being used for domestic civil aviation, navigation part. And again, very important one, what I'm writing here, you have to remember that. It is not GPS. Very important to remember that. Gagan is not a GPS. What is GPS? I have discussed in the classroom, various satellites in different orbits. Gagan is simply what is called satellite augmentation system. Right? It's called SABS. इसको कहा जाता है SABS. Satellite augmentation system there. Augmentation based system. ये बहुत सिंपल तरह से मैं समझा देता हूँ क्या इसका मतलब होता है, इसलिए नाम भी यहाँ पर दिया हुआ है. It incorporates, it uses the communication satellite like GSAT. And the GSAT is linked with the American GPS. is ऐसा है यहाँ पर, जैसे कि for example, you have the photograph also, but I'll draw just simple diagram here. Let's say there is a US GPS. There is a platform of American GPS Navstar. So what it does that, we are using the GSAT system of satellite. And let's say you have the tower, air control tower. In the airport, you have seen that air control traffic tower is there, right? So it uses the GSAT, but GSAT is being augmented with American GPS. And how it happens there? Let's say an aeroplane, which is there in the flight there, right? So what happens is normally the signal comes from here, a traffic control tower, landing, takeoff, vertical movement, right? But what will happen here? Now the pilot, here the signal can be done through this one, satellite. Did you get that? What is the main aspect? Any traffic control, the signal, it comes from the GPS system, this GPS, and then it happens in this. It's interconnected in this way. But now it is a bypass through GSAT. Why it has been done? To become more accurate. So it is using the GPS of America. We are using American GPS. But it is in between sandwiched by GSAT system. तो यहाँ से डेटा आता है, इस जगह जो है ये GSAT के थ्रू जो है यहाँ सिस्टम पे इंफॉर्मेशन जाएगा. All the data will be relayed through the communication satellite GPS, like this GSAT. Now what advantage will get? Bad weather, right? Bad weather, or sometimes in terms of more safety, accuracy, this Gagan system can help. This is how we have done that. Okay? So we have 3 satellites. You can see that it is linked with GPS system. You have seen the photograph. One aeroplane is between, and you have GPS system, and then you have GSAT. It gets connected to that, augmented. ठीक है? जबकि नाविक जो है actual GPS है वो, regional GPS में आता है. Right? So I'll end up with the class here with all this what I've explained here. I have given you that one aspect. I'll discuss that one. What do you do is that? Next class, my request to everyone in the classroom is that just what you can do. This what I have explained here with all this in slides and everything. This part of it, this document here. So when you go to student portal here, this part, I have given this achievements of DOS 2016 from PIB, Press Information Bureau. Up to December, whatever the launches were there, it is all given in one page. Just go through it, we will discuss in the next class. Right? So just be thorough with that. So any aspect which comes there, at least we are able to link with that. Okay? Now, concept clear? तो वही होता है ना, गर्दिश में हो तारे, मत घबराना प्यारे, right? So people should not be totally in a way thing there. Everything is there, it will be there, right? Or always remember that the approach, what you develop, that is much better. वो most important है. If you know the way out, it will not be difficult. अब आप लोग इतनी मेहनत करके क्लास में आ रहे हो तो कुछ तो उसका फायदा होना चाहिए ना. वीडियो एंड ऑल देखने में अच्छा लगता है बड़ा साइज में. देयर इन द ऑनलाइन पता नहीं चलता है वो क्या है. When you see a teacher live, that gives more better thing, right? More interactive as compared to what you see in the video. Anyway, who is Abhishek Kumar here? Who is Abhishek here? No one. Acha, you were. You gave me in that Facebook. अच्छा. फोटोग्राफ क्यों नहीं दिया अपना? मैं ढूंढ रहा था तब तक कौन है. कितनी बार फेसबुक खोल के मैंने देखा कौन है अभिषेक यहाँ फोटोग्राफ में. इसने फोटोग्राफ ही नहीं दिया, बताओ. मैंने कितना फोटो खोजा, कहीं चेहरा दिख जाए मुझे. Now I got in there. Anyway, we'll meet in the next class, right? Okay, thank you everyone.